Welcome everybody to GrafanaCONline 2021. So I'm going to start talking to you about unifying alerting. I'm going to cover the investment and the direction and the community feedback that we've been receiving. When I'm done, then Awana is going to give you a in-depth demo of the unifying alerting that we've been working on. Sophia is going to give you a picture of how we solve the API problems. Josh will give you a deep dive into the architecture, and Kyle is going to give us a picture into the future of where we're going with unifying alerting from here. He's also going to show you how to activate unified alerting for yourselves. So first off, what is alerting? We haven't talked about alerting as much as maybe we should have recently at Grafana. Many of you already know what alerting is, but not everyone does. So let's start by defining it. When something breaks in your system, you don't want to wait to find out until your customers are calling you. You want to be told. So this is what alerting is for. You define queries that detect bad behavior in your system, and when the query is matched, maybe a threshold was exceeded for a certain period of time, then you receive a notification. Maybe you get a Slack message, maybe you get an email. So how have we solved alerting at Grafana up until now? Actually, we've had two different solutions going on. Within open source, Grafana users created the alerts by creating graph panels. And then within those panels, people would set up notification channels to various notifiers, including email, Slack, Discord, webhooks, also others. The alert rules could query backend data sources that had alerting enabled. On the Grafana Cloud side, we were offering an alerting plugin that wraps Prometheus alerts. Within Prometheus alerts, you can create those alerts using YAML. So you'd also define the routing within the Prometheus Alert Manager. And the community has been using these things, both the open source community and the cloud community, and they've given us feedback. And basically what they're saying is, we want more. The open source Grafana alerts haven't been powerful enough. You couldn't create more than one alert per panel. So what people were doing was, for example, if they wanted to monitor multiple servers, they would copy the panel, recreate the alert, and then manually change the name to match the right server instance. And that was annoying. And if they didn't want to actually see the panel because they created it just for the alerts, then they would also have to go and hide that panel, and they'd have a lot of hidden panels running around. But for the creating of the alerts, people really loved the ability to work within the visual data and to drag a threshold visually to the right level. This is a capability that was missing in Grafana Cloud with a thinly wrapped Prometheus alerting. The Prometheus alerts in Grafana Cloud didn't have visualizations to help you edit your queries. Also, users couldn't create alert rules across multiple data sources this way. So we had people working on Grafana open source, and we had people working on Grafana Cloud, and we were splitting our efforts as well. So this was not ideal for Grafana Labs either. We wanted to unite our efforts and to create a single alerting solution and to work on this for both the open source and for the cloud users and customers. So what we did was we went in and we created a new system that's consistent across Grafana open source, Grafana Cloud, and Grafana Enterprise. We've unified all of this into a single open source feature that should improve the experience for our open source users and for our cloud customers. And it also makes it easier for us to continue to improve alerting going forward. So before I pass this off to Awana, let me go into some of the definitions so that you're not encountering this terminology for the first time. An alert rule is a named alert with a type and a query and a trigger condition. A contact point is basically a communication channel. This is like your telephone number in a phone book. It's it's where you're informed when an alert is triggered. So this might be the Slack channel that your SREs are all subscribed to, or it might be an email address. The notification policy will tell you which alerts go to which contact points. So you might have more sort of informative pieces that go to an email address where they can be handled when people have the time or when they're going through their emails. For more urgent things, you probably want a page. And for debugging purposes, or for when you have a lot of alerts all at once, and you have one of the alerts is already triggering when the others come, you can create a silence, which then shuts the notifications for an alert down for a specific duration. So I hope you're as excited as I am about this demo. I'm really looking forward to it. Let me pass it off to you now, Oana.
Thank you, Maral. That was insightful. Hi, I'm Oana. I'm a senior UX designer working for Grafana Alerting. Now let's go to the exciting part of seeing the new alerting system in action. I have here a working demo. Right. Probably you'll be starting with creating a new alert rule. To do so, in the alert rules listing, you'll see a button called New Alert Rule in the top right corner. And if you click on it, you'll be taken to the alert rule creation wizard. You'll start by giving your alert a name. I'm monitoring my Linux machine, and more specifically, my CPU load. So I will give it an appropriate name. Let's say Linux CPU. And the second thing is to choose an alert type. We have two different alerts. The first one is Grafana managed alert, which is what you have used in the past. The second one is a Cortex or Loki managed alert that is based on Prometheus, and that required a compatible data source. I'm going to select the first one, Grafana managed alert, and I will add it to a folder. In my case, I already have created one called Linux. All right. The second step of the wizard is to create a query to be alerted on. So I'm going to go to the query editor and select my data source, in my case, Prometheus. And I have here a query that I'm going to copy paste. And as you can see, it's already working. I have 4 different cores in my CPU. Let's say I want to set a threshold for this alert and to be notified if the CPU is over 0.02. Okay, I will make the threshold this low so you can see very fast how the alert is firing. All right, let's go to the next step. 3, define alert condition. So I already have my classic condition defined, and I want to make sure this is already selected because this is what the system will alert upon. I will leave the evaluation time as it is and go to the 4th step to add details for my alerts. Here you can add different type of annotations, runbook URLs, or other useful information. I'm going to write a very short summary. Let's say Linux CPUs are on fire. And the last part is to give some custom labels, to define some custom labels. So labels in general are useful because they will help you filter the alerts you have created, silence, and also route those alerts. Let's use some very easy to remember labels. Machine equals Linux, and one regarding severity. Severity equals warning. All right, that was it. I'm gonna click save and exit. So my alert rule, this is it, the one that I just created. Probably pretty soon it will be firing. Okay, now that I have my alerts, the next thing that I want to do is to create a contact point so I can get notified on different systems when things are happening. So I'm gonna go to the contact point tab. I already defined 2 different contact points, one email and one type Slack. Let's have a look. So I give it a name. Let's say the SRE team should receive the alerts on Slack channel. I added the recipient channel. In this case, it's called testing alerting, and I have used a webhook URL to connect it. I can also add a new contact point type, and that will allow the SRE team, for example, to be notified at the same time, both on Slack, email, PagerDuty, depending on what you add in here. To just for the demo purpose, let's leave it to Slack. So I'm going to save this contact point. All right, now I have my alert rules and I have the place where I want to receive them. The last thing that I need to do is to create the link between these two things. And you can do so by going to the notifications policies tab, where you need to route your alerts. There is a default, it's called a route policy, and that is a default for all the alerts. So you will set a default contact point, and all your alerts will go to that contact point. But you can also define new ones based on labels if you want to be more specific. So I'm going to go ahead and click new specific policy because I want all of my Linux related alerts to go to a different contact point. So let's say machine equals Linux, and I'm going to choose SRE on call, which was a Slack contact point type. I'm going to save policy. All right. And it will usually takes a few seconds until you'll receive it on Slack, but let's have a look. In the meantime, I have Slack open, and here it is. I'm receiving an alert. All right. There are times, on the other hand, when you might want to stop receiving alerts for a given period of time. And you can do so by creating a silence. So you can go to the silences tab, and you can create a new silence from scratch. Also by using the labels that you have used for your alert rules. So let's say I want to silence all under a certain severity type. And I'm going to use severity equals warning. Okay, let's say as a comment, investigating mode, and I can choose a duration. So the default is 2 hours starting now, but you can specify something in the future, for example. Let's leave it as it is. I'm going to click submit, and here it is. My silence is now active. So I'm not going to receive new notification for those 2 hours. What I can do, of course, I can edit the silence, or I can expire it, basically, unsilence. And immediately I can, if I made a mistake, I can just click the button to recreate it. All right, so this is one way of creating new alerts rules from scratch. You can still do it by coming from panel edit mode. So I have here a dashboard. I use the same query basically, and I'm going to click edit. And in the alert tab, this time I'm not going to see the rule form, but I can create an alert rule by clicking this button. And this will take me to the alert rule creation wizard with information pre-filled, like the query is already pre-filled, the alert name is in here. I only need to select the folder. You can also use different type of conditions. So instead of classic conditions, for example, you can use a reduce. I'm going to choose input A, and then I'm going to add a new one, a math condition. And let's say everything in B that is over 0.02. I need to use a point. In this case, I should receive an alert. All right, if I'm going to click run query, I'm already seeing my time series and how it looks. So I need to update, on the other hand, the condition, because this time I want to be alerted on the C expression, my math expression. So I'm going to change it. And maybe I can change the evaluation time to something faster, say 10 seconds for 10 seconds. All right. Because you are coming from a panel or a dashboard, you can also see dashboard UIDs and panel IDs in this case. And again, you can create a label machine equals Linux. All right, and I'm gonna click save. Now, this time I'm taking back to the panel edit mode with my alert being created. Okay, so let's go back because the last thing that I want to show you is the alert rules listing. You have the opportunity to use some filtering in here. You can filter by the data source, by the name or the labels, plus, of course, the state in which the alert is currently in, like firing, normal, or pending. Also, quite useful, you can choose between two different types of viewing options. One is the groups, where all the alerts are grouped under a folder or namespace. Could be useful for you if you are in edit mode, or you can go to state if you are investigating alerts, and they will be grouped by their, of course, state, starting with the firing one. So it could be a lot easier to see what's happening right now. Okay, and if not, you can also go back. All right, that was it. I hope you enjoyed the demo, and now I'll pass the presentation over to Sophia. Thank you.
Thank you, Anna, for the great demo. I hope that you all loved it. That was all possible because of the unification of the backend APIs. Hi, I am Sophia, backend engineer at Grafana Labs, and I would like to talk a bit more about this unification. So what was the situation before Grafana 8 and why that was not possible back then? So if you are a cloud user, maybe you are already aware that Grafana Cloud metrics using Cortex and Grafana Cloud logs using Loki already had an API that was inspired by Prometheus Alert Manager API. And there was an alerting plugin that would interact with this API for listing and editing rules. If you have ever used Grafana alerting, then you probably also know that alerts used to be tightly connected to dashboards, and there was no API for managing directly alerts. You had to edit alerts from inside the dashboard panel, save the dashboard, and then through the dashboard API, the dashboard JSON would be parsed, and the alerts would be extracted and updated appropriately. So we made significant changes to the existing Grafana backend in order to implement the same API Cortex and Loki use. The benefit of this is that clients using this API can create alerts from across different systems. And that's what the new alerting experience takes advantage of and places all the alerts from the different systems and different data sources into one place. In addition to this, we now send everything to Grafana first, and that's what you see in this screen. So when Grafana receives a request, checks the recipient URI path parameter, and if it's Grafana, then the request is sent to the appropriate API handler under Grafana backend. And if the recipient is a valid data source ID within Grafana, then the request is proxied to the appropriate Cortex or Loki data source. But we needed also a way to define such Grafana managed rules and notification channels using the new API. For doing so, we have extended the request payloads so that they support both types of rules and receivers. So now, before processing a request, we made some cross validations to make sure that payloads are consistent with the destination backend. For instance, we don't know to send to Cortex a payload that contains Grafana managed rules. And also, we don't want to send to the alert manager that is embedded now in Grafana some configurations that Grafana does not understand. Also, the Alert Manager API expects a YAML instead of JSON. Therefore, the backend translates the payload to YAML before sending it. Finally, the new API like Loki and Cortex API, has an open API specification together with all its benefits, as like automated documentation and code generation. I would like to conclude with some features we try to preserve. Dashboard alerts were subject of the permissions, the directory and the dashboard under which rules used to live. So in the new alerting, rules also live under folders, and in the API level, rules are organized under namespaces, which actually correspond to such Grafana folders. For enterprise users, there are also data source permissions. So if you have, you cannot create an alert querying a data source that you don't have a right to access, because this data source is invisible to you. Another feature is quota, and if it's enabled, then the administrators can limit the number of alerts users can create. Finally, secrets of the notification channels are stored encrypted in the database, and we make sure that we don't expose them when we retrieve the alert manager configuration. I believe that now you are curious enough to know more about the alert manager integration I mentioned before. So I will leave you to my colleague, Josh.
Thank you, Sophia, for shedding some light on the unification of our APIs. I'm pretty excited about this, as it will help us ship new features much faster, given we no longer have to worry about different interfaces between the alerting components across our stack. Hi, everyone. I'm Josh. I'm a software engineer here at Grafana, and I work mostly in our alerting stack. Speaking of alerting components and being conscious that the title of my presentation pretty much gave it away, I'm pleased to announce that we have fully integrated the Alert Manager within Grafana. Grafana 8 now ships with an upstream version of the Alert Manager embedded. So not only we don't need to worry about differences at an API level, but alerting semantics remain the same. What do you really mean with semantics? I'm talking about what I like to call the 4 pillars of alerting: routing, grouping, deduplication, and silencing. With the new routing system, you can define who receives what and how in the very familiar tree-like structure that characterizes the alert manager. All alerts aired in the routing tree at the configure top-level root, then traverse the configuration child nodes, typically specify how do you want the alert to be delivered. Next on the list, it's grouping, which helps us categorize alerts that are similar into a single notification. Think of the common scenario where you want to group your notifications by alert name and cluster. With grouping support, you can now define how this batching structure looks like on the notification side. The duplication, it's always an interesting one. For Grafana, there's no changes in this area though. Grafana's high availability mode has always supported this, and my statement is more of a reassurance that we'll continue to do so. And finally, and probably my favorite bit, as you can see from the screenshot on the right, it's silencing. Now we have a way of silencing notifications for a predefined period of time without having to halt the evaluation rule. Silencing also brings support for inhibition rules, which at its simplest form, it's a way to auto-silence an alert based on whenever or not another one is already firing. This really helps manage the number of firing alerts under total failure outages, where the high number of firing alerts at the same time would overwhelm the human on the pager side. And that's that. I'm stoked that we have managed to unify semantics in the alerting system, and I'm confident that this will bring you joy as you progress through your observability journey. You'll be able to move or use different systems with as little friction as possible. Up next, I have my buddy Kyle, who's going to walk you through the future of alerting.
Thank you, Josh. I'm happy that we chose Alert Manager to integrate with, and I'll explain a little bit more about that later. My name is Kyle. I am a backend engineer at Grafana. I've been here for a couple of years working on backend data sources and alerting, and also server-side expressions. We've had some top Grafana GitHub issues around alerting. A couple of them are multiple alerts per graph and add alert support for single stats. These have a lot of thumbs up and smiley faces and a couple sad faces. But Torkel said, maybe if there's huge demand for it. Well, the demand has definitely been met, and then some, I think. So we can close these now, actually. And the future, I think, is just going to be making them better and building on top of it. So presently with dashboard alerting, there's a fair amount of toil involved. If you have a bunch of servers and disks and you don't want an alert per server and disk, you had to create an alert rule for each combination. So one for Web 1s, et cetera, one for Web 1's home disk space, et cetera. So this is tedious work, and you can forget to add new things, and it also tends to create inefficient queries. So to do this, we're taking an idea from Prometheus, using its labels and essentially making multi-dimensional alerting. So what this means is you can have one alert rule and create multiple alert instances from it, and I call this multi-dimensional alerting. So your data will have these different dimensions, which will be factors or facets of your data, such as host equals Web01, or the location is LGA. So for example, if you have a single alert rule that can query for disk space and create alerts, then you get one per host and disk. So this is a more powerful system in terms of leverage with your alert rules to alerts. So as an example, we will use SQL. Imagine you have a table in your SQL database. It has some timestamps, it's time series data. You have host labels, disk labels, and %free. So what we do is we can create a single rule that queries on host and disk, and we include a case statement on the %free, where if it's less than 5, our threshold, then we will return the %free, else we return 0, and 0 is not alerting. So in this way, we get not actually time series, but single stats back. So the query, the data being returned to Grafana is single stat and it's multidimensional. So we're achieving both of these in this. And then when we do this, we get an alert per host and disk. And this works out nicely in terms of integrating with Alert Manager, as Joss was showing, in particular grouping, because you can control how you want these labels to be grouped into notifications without actually changing your queries, which I think that decoupling is a very good design choice from the Alert Manager team. This is also meant to be data source agnostic. So we have an example here of Prometheus is returning data, MySQL is returning thresholds, and then we're using these server-side expressions to compare the two and generate whether it's alerting or not. So what is the future? We want to build on this new foundation and make the future ready to remove dashboard alerting from Grafana and move to this new system. So we want to improve the workflows and make them more intuitive and informative. This, like I said, the system is a little bit more powerful. You have that lever of one alert rule to multiple alert instances. So that needs a little bit more feedback to make sure you can control what you need to control for good alerts. We need to provide more information and notifications to give context. There's still some aspects to solve. We don't have provisioning for the new alerting system yet. And of course, we need to collect feedback from all of you and make sure it's what we need. The users are getting what they need so we can go out of beta. So then I think continuous investment into alerting and Grafana from now on to restore trust. So those of you that have been using Grafana alerting for a while, we worked on it and then didn't really put much effort into developing it over a long period of time, and we don't want to do that again. So thank you so much. In conclusion, I would suggest that you try out the new feature. You can try this with the feature toggles and enable the NG alert feature. After this is QA, so you can stick around for the QA to ask us any questions about any of the stuff you've seen in the series of presentations. And I am going to go close those issues, which I've been looking forward to doing for quite a while now. Thank you so much.
I hope you all enjoyed that. Now we're going to take your questions. We have quite a few, so we'll try and address as many as we can, and afterwards we'll be in Slack so we can answer them there. The first one, though, is a question on, is there an option to have multiple alerting windows, or rather timed silences, suppress them at sort of like overnight? And for that one, I'm going to point you to Josh.
Hello, everyone. Yes, we haven't really bring this into Grafana just yet. As you might know, and you saw from my presentation, we have managed to include Alert Manager into Grafana, and this made it to the Alert Manager in the latest version. So we're going to trial over there, given it's experimental, and if it works and it's stable, we're going to bring it into Grafana. So the TLDR to that is not yet, but soon.
The next question up has just been addressed by the actual demo. And this is, Carl's going to answer this one, but is there a way to use template variables for the alert thresholds?
So there's, you can't use template variables because they're a part of dashboards, and these Grafana managed alerts are no longer part of dashboards. They live in folders. But you can do queries that return multiple things and have alerts per things. As far as different thresholds, we don't have that kind of baked into the UI yet, but you could return it from another data source, or maybe do some other hacky things with the test data source. But probably the ideal there would be to file an issue, just so we can expand upon that. And you can also navigate from dashboards to create an alert rule and go back from the alert rules to dashboards too. So we try to keep that dashboard flow the same.
Thank you. And the next questions, actually the next two are essentially the same thing, which is this already available? How do we enable it? Now, we just saw that in the demo, but I'm going to pass straight back to Carl because he can answer it again.
Yep, it's a feature flag. So if you enable the ng alert feature flag, which you could find in the config file, the ini file for Grafana, it will move to this. Once you enable that, all existing dashboard alerts will be migrated into this new alerting system. When you remove that feature flag, all new alerts will go away, even new ones you created that were not migrated, and you'll be back to the old system. So that's how that feature flag works in combination with migrating dashboard alerts.
Cool, thank you. And we'll actually put information in the Slack just to make that cut and paste for you. And the next question up, the next most popular question is, do the alert notifications still support embedded images in channels that support them? And for this, we're going to go to Sophia.
Sorry, can you repeat?
Yes. Do the alert notifications still support embedded images in the channels that support them, i.e. when they go to Slack or to email?
Sorry. Yes, we currently don't support that, but we plan to revoke this and be able in the future to have some images rendered in notifications.
So that will be coming. It is something that's definitely on our roadmap. We just didn't get time to actually put that in time. A more interesting sort of complex one is, how does the unified alerting that we've just done compare to something like Prometheus Alerts Manager? Now, Alert Manager has been out there for a long time, and a lot of people are very familiar with it. This is a very big difference. So for this, Josh.
So in terms of semantics, we can say that they are one-to-one, actually. We have managed to embed the grouping and the duping and silencing parts of the Alert Manager into Grafana. So the same type of functionality that you're used to using with the Alert Manager, you'll get it for free now with Grafana.
Great. And next question is, where do we store all of these alerts? I'm going to go back to Sophia for this.
So Grafana managed alerts are stored in the database. So whatever database backend you have configured, that will be stored there. And Prometheus, Cortex or Loki, I think that support different stores, so they can they still continue to be stored wherever they used to be.
Cool. I'm going to take the next one. The next one is, does the alerting support only the Prometheus data source or all of the different data sources? So I'll take this. And essentially, the point of the unification here was that if you're doing your Prometheus alerts and they're outside the system, you can now manage these through the unified alerting. But all of your existing data sources that you were doing alerts for can also be managed through the unified alerting. So everything is available to you there, and you get the same power that you had from the Prometheus Alert Manager for your Grafana data sources as well. So that was really the main primary purpose of this. To answer that question, everything is now one system. The next question up is there a way to silence all of the alerts? Example here being for maintenance over a busy weekend. And Awana.
Yeah, you can already do it. All you will need to do is use a regex, aka a regular expression, on a label to target all alerts. Like, for example, you could say alert name equals point plus, and that will target all alerts that you have. That's it.
Great. We're going to go straight back to you, Awana. Is it planned to implement some kind of autocomplete for labels and values and notifications, or some match checker to make sure that to ensure that it matches needed rules?
Yes, we do have it on our roadmap, and I know there has been a different question also when it comes to silences, so maybe worth explaining. Right now, the other question was if it's possible to create an alert silence directly from a firing alert. Basically, because using key value pairs for labels is not the easiest thing to remember, right? You have to have two tabs open at the same time to see what you have in one place and then reuse it in the other. So one, we do plan to support in the near future autocomplete. And the second one is, yes, we also want to be able to let the end user silence an alert from the alert rules list and not only from the silencing tab. We understand it's a big experience improvement, and hopefully you'll see it live soon.
The next question is the new alerting available only in OSS or only in Enterprise? Like, exactly who gets this? Mel.
Of course, it's available in open source. And because it's available in open source, it'll go into Enterprise too. So we're really happy to be able to give everybody the unified alerting.
That's great. That's the best news. Andrew asked an interesting question, which is there a way to use an external alert manager instance? This will definitely be for Josh.
So we can say yes. You have currently one of the notification channels. We can actually point alerts to the alert manager, but they would come more in the form of a webhook, right? So you'll need to do all your routing, grouping, and deduping in the Grafana alert manager instance, and then send it over to the external alert manager if you want to do something else with them. I'm going to reveal that we're not pleased with the way that this has worked, and we're in the works of doing something that integrates a little bit better. But that's going to come probably for 8.1 or after.
Great. Back to Awana for this one. And this one's going to catch you out. But it's, can we implement things like burn rate and multiple alerting windows?
Not sure if I know the answer to that one, to be honest. So maybe somebody else could help.
Cool. This will be, I'll just answer with a, hey, oh, Kyle, did you want to take it?
Yeah, so if you're using the Prometheus alerting, there are, I think, examples out there of burn rate style alerts and stuff like that. So that's pretty clear. If you're using Grafana managed alerts, if your data source can do that math, probably. Maybe with the current state of expressions, you might be able to do it, but that would be something we'd want to improve, add more expression operations so you're able to do more calculations if it can't yet.
The other thing here is that now we've finally launched this, you can totally open a ticket on Grafana and we will pick it up and we are triage and we will take it on. So please give us information as well. Next question is, what about Thanos data source? Aside of Cortex, is that also supported? I'm going to go back to Josh.
So the reading part, yes, it's supported because it's the same Prometheus APIs. In fact, your Prometheus API, it's also supported, and you're able to see your alerts that are firing from your Prometheus instance as well. The actual putting up configuration or the actual creation of alert rules is not, because Thanos doesn't have an API for this. But yeah, I'm pretty sure that at some point the Thanos community will get together and implement the APIs for this.
Thank you. The next one's, I probably don't have an answer for this. I'm not sure anyone here does, but we can definitely try and get back to the answer on this. Ronald asks, there are some standard notification channels. What's the best way for a vendor to get an additional notification channel in? I would suggest that this is the best way is going to be via the Grafana repo. So if you actually open an issue there and raise that as a PR, we can actually look at that, evaluate it, and then work with you to actually get it integrated. That's the best I've got there, unless someone else is going to put their hand up.
I think that's time for us, D. So.
Cool. Thank you very much. That is us done with the questions, which is all the popular ones. And there are some more, though. We will take those on in Slack, and we will see you all in there. Thank you.
Thank you.
Bye, everyone.
Bye.
Hello, everyone. Thank you so much for joining us today at GrafanaCONline 2021. I hope you're enjoying the sessions we've put on so far, and I'm really excited that you're joining us for this one, as it's about a topic that's very near and dear to me, and I imagine many others. But before we get started, let me introduce myself. I'm Jessica. I'm an engineering manager here at Grafana Labs. But before I was an engineering manager, I was working as like a site reliability engineer, or whatever the particular flavor of the month was at that point in time. But you know, the usual managing infrastructure, deployments, making sure pipelines are working, making sure our infrastructure is working, you know, how do we scale things, these sorts of things. But, you know, the most important thing, obviously, I thought was monitoring it all. So I've been using Grafana for a number of years. So that's what's brought me here. Anyway, so late last year, my manager came to me to ask me about something he knew instantly that I would be interested in, and he was correct. Back then, it was simply being called dashboards as code, which, as you know, naming things is very hard in engineering. Immediately, though, my mind began to race with all of the possibilities. Dashboard management, user management, deploying dashboards alongside various infrastructure that we already had as code, you know, making it easier for operators to maintain GitOps workflows. I mean, the possibilities seem endless even now, the more that I've been able to think about it. But anyway, I'm getting ahead of myself. This complex problem is something that a lot of us are working on here at Grafana Labs, and we're really eager to show you what's in store and hoping that you'll be just as excited as we are. So let's go and see what the engineers who are working on this immense problem have in store for us. Today, you'll be hearing from a range of amazing people who are working from all over the R&D department here at Grafana Labs, and they're working on this together. We've got Malcolm and Sam from the Cloud Division, and then you'll also be hearing Ying, who's with me in the Grafana division. But so without further ado, I'm going to pass over my mic to my colleague, Malcolm Holmes. Malcolm?
So thank you, Jessica. So hello, I'm Malcolm. I'm a senior software engineer here at Grafana Labs, where I've been working a lot on dashboards as code and automation. So one scenario we see often with large Grafana installs is where we have a single dashboard that has lots of people interacting with it, making small changes, and it can become hard to track the provenance of that of such a dashboard. You know, who made what change and when. Maybe sometimes we'll see people taking a clone of a dashboard and making small edits, and then we no longer know which one is actually the master, which one's the real one, and which one's one we should ignore. Or maybe we have edit wars where someone prefers green and someone else prefers blue, and one person changes it, the other person changes it back, and so on and so forth. But they don't necessarily know who was it that made that change, and was it important, and does it actually make a difference? But in software, we've solved this problem long ago with version control, whether it's, you know, CVS, Subversion, Git, GitHub. We know how to do this. So how might we integrate this? How might we integrate this sort of software engineering workflow into our Grafana installation? So let me have show you a quick demonstration. So here we have an extremely sophisticated Grafana dashboard, single panel with a random walk graph, but terribly, it's green. I don't like green, I prefer blue. So let me change it to blue. One of the most sophisticated edits you'll see anywhere. Okay, right, so what I'm going to do is I'm going to save that, just say I prefer blue, and save. So what's happened here now, what we've actually got connected to this Grafana instance is a small tool that's listening for save events. So when this dashboard was saved, this tool connected to the Grafana instance, pulled down the JSON for the dashboard and pushed it up to GitHub. So let's have a look at what we've got over on this GitHub tab here. So if I reload this page, we can see there is the latest commit, I prefer blue, by me. And what we can see is I've changed the dashboard from green to blue, and you can see there's an increment in the version number. So now we have a very clear rendition of a clear representation of what changed in this dashboard. So we have a very clear representation of the changes, and more importantly, we have a nice blue dashboard. Well, we had a blue dashboard, but it's gone green. What on earth has gone on here? Let's have a look and see if GitHub can tell us. Let's go back and look. There you go. Okay, so clearly we can see Ying prefers green. She's put it back from blue to green. I now know who I need to complain, no, sorry, who I need to go and talk to about getting this fixed, about working out what the right color is, what the right solution is. So as well as having a clear representation of a difference, a small diff here, for more complicated dashboards, we might want to have more, we might need to understand the structure of the JSON more and what each particular element means. I'll say more about that in a bit. But first, let me show you a quick another way that we could solve this problem that Ying and I have. What we have these two needs. One basic dashboard, but it just wants to differ in two ways, in one of two ways, or two variants of the same dashboard. What we can do is we can use a programming language called JSONit, which is just a programming language that is used to render configuration, in this case, JSON. So here is the JSONit. So you can see here, I define a panel function to define the panel. It takes in a name and a color, and it gives me a graph panel, and it sets the name, and it sets the color of the panel. Then I say, make me a dashboard, and it takes in a name and a color, and then it adds a panel that has that name and color to my dashboard. And here's the important bit. So we've got the dashboards. So we create two dashboards, one for me, named Malcolm with a color blue, and another one called Ying with a color green. So now we have one definition of a dashboard, but with two instances of that with a small difference. So what on earth, how can we use this? How can we get this into my Grafana instance? Well, we can use an experimental tool we have created called Grizzly. This will push this, render the JSONit into JSON and push that up to our Grafana instance. So we can now see it's created our two Grafana dashboards. If we come back to our Grafana instance, and actually we go home and here, and there you can see we have a dashboard called Malcolm, which is blue. Good, that's how dashboards are supposed to be. And we have a green one here. Good, that should at least keep Ying happy. Now we have no more conflict and we can get on with more important things. So coming back to this dashboard definition here. So you can see there's quite a lot of sophistication going on here. We have knowledge about how to add a target, how to set a grid position, how do you set the color for a particular element. You'll notice here I've added some JSON, whereas here we've got a function definition. So all of this, there's a lot of complexity there in terms of knowing how we represent a dashboard and what does the JSON that we end up with actually mean. And that's something that we been putting a lot of thought into. And to cover that topic, I'd like to hand over to Sam.
Thanks, Malcolm. So Malcolm showed us some of the existing tools and techniques that allow us to get dashboards out into code, as well as go in the reverse direction, where we go from code to a dashboard and a UI, whether that code is pure raw JSON or some more sophisticated software for generating dashboards. And these techniques, they fundamentally do work. We use many of them internally at Grafana Labs. But the fuzziness and uncertainty around dashboard JSON that Malcolm described, exactly what it all means, what it's supposed to do, whether it's all going to continue that way, it makes scaling these techniques a challenge. The root of the problem is the dashboard JSON itself. Dashboard JSON is essentially a private API that accidentally, gradually, organically became extremely public. We affectionately refer to it as the big blob of JSON. As a result, all of these code-centric tools and techniques are burdened with at least some amount of half-blind reverse engineering that they have to do. Now, when I think about getting better, about working effectively with big, undifferentiated masses of stuff, I think of a story. It's 2,500 years old. It's called The Dexterous Butcher, and I am absolutely not going to try to butcher its author's name. But I want to read a quick excerpt from it because it is just stunningly applicable. When I first began to cut up oxen, I would see before me the whole ox, all in one mass. After 3 years, I no longer saw this mass. I saw the distinctions. But now I see nothing with the eye. My whole being apprehends. My cleaver finds its own way. I cut through no joint, chop no bone. A good cook needs a new chopper once a year. He cuts. A poor cook needs a new one every month. He hacks. I've used this same cleaver 19 years. It has cut up 1,000 oxen. Its edge is as keen as if newly sharpened. If we want to stop hacking away at the big mass that is dashboard JSON, forever cursed to toilsome work with dull tools, then there's only one path out: knowing the JSON. Apprehending the JSON with our entire being. Or in less metaphorical terms, we need to take this private API that incidentally became public and make it public properly. Formalize it, document it, put guarantees on it. That is, we got to schematize it. Now, this isn't some magic bullet. The reason the reverse engineering is unreliable is because to date, the front end treats generated JSON like a private API. It's not feasible to be deliberate about what's in there today as a front-end Grafana engineer. Schematizing, then, isn't merely a question of having some schema files. Having good schema is a process. It's about creating new systems so that it's not just possible, but worth the time and energy to think rigorously about the JSON in the front-end app. Which is why, maybe not so much schematizing, but schematizing. I'll explain. Grafana 8 is shipping with a new system that we're calling Schemata. It's a system for defining, evolving, and using schemas, and it's written in this new language called Q for reasons we'll see more about later. We're also shipping some schema for dashboards and for panels, but they're immature. They're still in the process of becoming good schema. Even though the schema themselves are immature, though, we know a lot about how we're going to be able to use them, the types of guarantees they're going to provide. Some of what you're going to get from it is a lot of what you'd expect from schema systems, but some is also quite surprising. But I'm going to hand it over to Ying now. She's going to talk about some of those things from the first category, absolutely essential stuff that you could maybe guess we'll have.
Hello, everyone. My name is Ying. I come from the backend squad of Grafana team. I cannot survive this difficult year without my dear family, my dear friends, and my lovely colleagues. But indeed, I had a good time. I hope you too. Today, I'm going to present to you what we have done for this feature in V8. The dashboard as code, you can also call it massive dashboard management. Some already present, what are the schemas and what are the reasons behind why we choose these technical solutions. And for V8, we are mainly focused on two things regarding this feature. One is simplify the dashboard, simplify the process. The second one is verify the dashboard, make it more reliable. Dashboard JSON, of course. Let me show you what I mean by simplify. So we all have this experience that when we export dashboard JSON, we easily get thousands of lines. Not all the information inside are very, very valuable, right? There are certain fields that we barely change between different dashboards. So in V8, we introduce this feature to trim and apply default value when we export and import dashboard JSON to reduce the size of the dashboard JSON. When you click on a shared dashboard or panel, export, you have one new option, export with default value removed. Let me just keep the original dashboard JSON to compare. Okay, here is the full JSON. We can see that even the dashboard contains only 4 panels. It's already 600 something lines as a dashboard JSON. And now I'm going to use the new feature to trim the default. I save it to my computer. Here we go. So if we check the dashboard JSON exported, we can see it's 500 lines. Okay, let's say 15–20% trimmed off is not allowed. It's because currently we didn't finish to define all the schemas, for example, for core plugins or external panel plugins. As soon as we have all of these schemas defined, the percentage will be much more. Okay, just to show that we trimmed all the defaults. If we go back to the schema definition, the Q schema for the dashboard, we can see that under time picker, we have refresh interval, which has a default value with the star, that means default, and it is an array. If we go back to full JSON, we still have this, right? If we come back to the trimmed default version, it is gone. Okay, let me now to import this trimmed version of dashboard JSON to see that for the import, it will recreate exactly the same dashboard. Let me choose import. I will need to change the name because I have the same dashboard before. Has the same name again. Also the UID. Here we go. Voila, we recreate the same dashboard with the trimmed dashboard JSON. Okay, this is the first point. We mean simplify the dashboard JSON. The second point, verify. What is verify? So if I go back to my dashboard definition, we can see that panel type is mandatory because it doesn't have this question mark. That means it's mandatory field in queue. If I go back to my schemas and find one panel here, here we go, panel type graph, if I remove it. We import the dashboard JSON. I just added it. Change the name. Import. I will get an error while applying default. I know the error message is not very explicit now yet. We are working on it to improve, but at least now, if your dashboard JSON is against the schemas defined, you are not going to able to import it anymore. So it avoids the problem as before that you can import dashboard JSON into DB and then you will find out on the UI that the dashboard is broken. Now it's blocked at import level. It is interesting feature, and one of my colleagues, Dimitri, is working on a GrafanaCONline. So you will in the future able to use GrafanaCONline to validate whatever the dashboard JSON you have, even manually created, generated with JSONnet, or exported from other Grafana instance. Okay, that's all on my side regarding what we delivered in V8 regarding the feature. I will leave the stage to my colleague Sam to present you what is our vision regarding the feature in the future, what we could do even more with all of those schemas. Thank you very much.
Awesome, Ying. Thank you for that. All right, now that you've seen some of the stuff we can do right now that you maybe could have guessed would be in a schema system, we're going to look at something quite different, or in true Pythonic form, maybe not actually that different at all. Start by thinking back to Malcolm's second example from earlier, where he used Grafana to generate a dashboard. That's super useful. So let's revisit it in our new world. Here we have a Q file. Like that JSON file Malcolm showed, we're importing something up here, up top. But we're not importing Grafana. We're importing the actual canonical Grafana dashboard schema directly. That's real path. It exists. Again, immature. But there's no special libraries here to find or track, just the schema. If we go down a little further, we're seeing some of the ugly bits of the internals, and I don't want to dwell on these over much. We're working on syntactic sugar, and even then this is still a little pseudocodey, but still. What's happening here is this path traverses the schemata data structure, which is what starts at the family here, to pull out a particular version of Grafana's dashboard schema. What's important is that the consumer of this, that's us, the authors of this file, can construct a reference, can write a reference like this to those schema that's stable and backwards compatible. And that reliable, predictable version of the schema ends up over here in dash schema. So given that, let's make a dashboard from our schema, which might sound weird, but it's possible because that's what Q does. Q types and values are fundamentally the same kind of thing. That means we can merge the dash schema or unify. That's the U in Q and the meaning of this ampersand operator here. We can merge the schema together with this declaration that we've made where, you know, magical rainbow unicorn toots and we're summing up the toot counts by unicorn name. Doesn't really matter. What's more important is the properties that we get out of this. First, the default values that are going to be filled in here, they're not coming from some random Grafana thing. They're coming from schema. So this is actually kind of the inverse operation of what Ying was showing us from earlier, whereas before we were stripping defaults out, now we're filling them back in, at least optionally. The second part, that was the really powerful one. It's that it's not possible to render out JSON if our declared dashboard actually violates this dashboard schema. And if we combine that guarantee with the earlier guarantee about a backwards compatible way of referencing schema, then it changes the character of the text in this file. This is not glue code anymore. The expression of intent here is unambiguous and precise. Its behavior is reliably correct in near perpetuity. That's never existed before. With knowledge of structure, our cleaver strikes neither joint nor bone. With foundations like these, we can start really thinking about safe manipulation at scale, which brings me to my next example. This is Poly. It's a pseudo acronym for Parameterized Observability Config Packages. It's a brand new multi-company OSS effort. This repo, as I speak these words, is only a few days old. It's the spiritual successor to Prometheus monitoring mixins, and it's all built by composing schemata. I'm going to pull up the core schema for this system, which is the Poly package. Now, this import should look familiar. It's the exact same one as what we had in our unicorn dashboard. But here we're not using it to create a dashboard. Rather, scoot down here a little bit. That's the same statement that we had before. This is actual real working code. This latest sort of ugly as sin system is part of what we're working on improving in terms of developer ergonomics. But the essential intent here is This is a sort of Go equivalent. This is a map with string keys pointing to instances of dashboards that conform to this schema. Now, I could fill a dozen presentations on what's happening with poly packages, and I would certainly encourage people to check it out. But for now, I'm just showing this to illustrate where this is all going. One of the many different ways in which this new schemata system is going to scale. Poly packages are defining a larger schema structure in which we're composing in schema, and now we've gone from operating on one dashboard to collections of them. Even still, though, all of these same schemata guarantees flow through. If we scroll up a little bit, we can see also part of the poly package is specifying that the package must have a URI, similar to a Go module. That gives us an addressable grouping for our set of dashboards. And a step yet further that I can't really show in code, we're expecting that organizations will be using many of these poly packages, potentially producing them as well, we hope, and leveraging the power of the Q language to manage, control, update, and constrain all of these packages en masse through familiar GitOps style processes. So clearly, what we're getting here is way more than just, is my dashboard JSON valid? Schematizing Grafana is tilling the soil for whole new ecosystems. Now, it's crucial to note, even though I am clearly wildly excited about Q, I do understand that learning yet another language isn't anyone's priority. Poly also illustrates how the benefits of schema and Q will flow both ways. Whereas Grafana and JSON have always been really code-only tools. You can do things in code, but you can't generate them per se. We do expect it's going to be perfectly feasible to tap at least some of Q's power from the UI, all thanks to schema. Having a schematized poly package means we'll be able to generate poly packages from the Grafana UI. Not as expressive as doing it from code, but possible. Again, this is all future stuff, though not a terribly distant future. So shall we get there? Let's talk roadmap. For the roadmap, what really matters is the maturity of the schema, which again, it's all about process. Grafana 8.1, we're looking to make sure that we have solid tools for checking schemata to support the authoring process again. And we also want to be at the point where the dashboards that we generate from our dashboard schemata, and much the way that these examples I just showed you work, these work well enough that the Grafana front end handles them. Grafana 8.2, we're looking to make sure that front-end generated JSON usually passes schemata validation, and that we have really clean, stable Go and Q schemata consumption APIs, referring to that awful syntactic, the need for syntactic sugar over that awful syntax from earlier. Finally, before Grafana 9, we are hoping that all front-end generated JSON must pass validation. Like in order to save a dashboard, it must pass validation. In other words, we're hoping that all the schemata will be canonical at that point. And I mean, that's kind of the finish line. So that's where we're at with Dashboards as Code today and where we're planning to go in the immediate future. We know the name Dashboards as Code doesn't kind of do the scope full justice, but hey, it's what we got for now. So please do feel free to reach out to us via some of the channels you see on the slide. Thanks to Jessica, Malcolm, and Ying, and all of you for spending this time with us. I hope you enjoy the rest of your GrafanaCONline experience.
Wow, I hope everyone enjoyed that amazing presentation. And thank you so much for joining us for a live Q&A, or well, semi-live. There's probably some delay because internets. Today we have me and Malcolm and Sam. Ying is sadly not here today, well, right now at least, because she's in Beijing and it's in the middle of the night for her. So we're gonna let her get her sleep. But I think that we can all hopefully answer a lot of your questions. So shall we begin?
Absolutely.
Right, so feel free to get your questions in. I'm gonna start from what I can see at this point in time. And yeah, so we have about 10 minutes. So let's see how many that we can get through. We have one from Daniel. He asks, or they ask, is there any way to convert a bigger dashboard to JSON it automatically, aka dashboards that are like larger than 1,000 or 100,000 lines of code?
So I did play with that possibility. It's not as easy as it seems. Firstly, you do need a schema of some kind, because otherwise you can't know what anything means. I did manage to convert a simple dashboard. It's something we can explore once the schema is in place. But actually switching to, as you've seen after I talked about JSON it to Q may change that game a bit. Sam, anything to say there?
Yeah. Since you need the schema in order to be able to generate this programmatic representation of a dashboard, anyway, I mean, really, one of the main cases that we want to be able to enable by using this Q-back system is to make it quite feasible to write out your dashboards directly in Q. It's going to be easier to do that than in JSON it. So the Q spaces, we're going to be targeting that. There's a lot that's uncertain about exactly how that's going to look. That's part of what we're thinking about with the poly packages that I showed. But this is certainly a goal.
It's a hard problem. Like, it's a very
Absolutely.
complex thing. So, right, oh goodness, everything's moving very quickly. So there's a new top one now, which is from Anonymous. They ask, will you open source the service watching for save and pushing to GitHub? I guess I can answer that. We don't know yet. But the PM that's responsible for helping us out with this and organizing all of that is saving all these questions. So hopefully we'll be able to answer these more thoroughly in the future. So, right. The next one is also from Anonymous, maybe not the same Anonymous, but how do you re-import all the dashboards on another instance? Is there any problem with dashboard IDs?
So dashboard IDs, yes, absolutely. They're fun. So again, as Sam was saying, the JSON schema that's currently in place was designed as an internal API. So it's reasonable to put database IDs into the JSON. And then sometimes when you extract it from the API, it removes the IDs, sometimes it doesn't. And that causes all sorts of problems. So I would say that those are some of the things that as we move further into this project, we'll be clearing up and resolving, making sure that the database IDs are more of an internal thing and not part of our user-facing API. The Grizzly tool that I showed does have the ability to pull a set of dashboards from one Grafana instance. So there's a Grizzly pull, and then you can push them back with Grizzly apply. So there is a function to do that. It's it's alpha code, but if it works, great.
Awesome. So there's a follow-up question from Daniel. I think Sam, do you want to address that? If you can also actually repeat the question as well.
Yeah, so Daniel asked, essentially, since the JSON is being retired as the main means of developing dashboards, they're wondering what will happen to many, many dashboards that are in JSON. That's not what's happening. JSON is still going to be the form in which dashboards are represented on disk. Similar to how JSON is a way of generating them, the Q-back system is a way of generating them. It is a little complicated to talk about Q in this context.
In so little time as well.
Yeah, in so little time, indeed, because Q is a language that is not a lot like what people have encountered before. This is part of the reason that we don't want to throw people into writing a ton of it, and people should not have to. But dashboards will still be emitted as JSON. We're not going to be replacing like the export JSON with export Q buttons in any foreseeable future. Q is much more about it both gives us the schema and then gives us these foundational tools to be able to build like packaging systems on the other side. But it's not actually replacing JSON as a form of representation.
Awesome. I hope that clears things up a little bit for you. Right, back to top questions. Daniel, you keep asking very good questions because they keep getting voted up to the top. So what service was that? The one that someone asked about being open sourced? I believe that was the one that Malcolm demoed around like more of a GitOps workflow. And I think that I think that's what people were referring to, but it's hard to tell with just this. So, and that's the one that I'm also telling about, that our PMs are on it about deciding which bits of this is going into what. But yeah, so right, next up then is Alexei asks how to resolve conflicts when several users are trying to save changes, which is all something we very much are very familiar with.
Yeah. So what we're in that particular Git workflow, what we're doing was we're piggybacking on a feature that's was in Grafana 7.3, I think, and definitely in Grafana 8. It was behind a feature flag in Grafana 7.3, which allows when you save a single dashboard, the Grafana instance listening on a WebSocket. And any other Grafana instance that has that dashboard open will be notified and potentially reload the page. If you've already made a change and someone else saves the change to that same dashboard, it will pop up and give you a choice. What do you want to do? Do you want to use yours, use theirs, and so on? So that conflict resolution process is already in place in that feature. We're effectively sort of pretending to be another browser.
Yeah, I mean, I think at least in the alpha and beta stages of this, it will be very much linking in with Git workflows that we're already very, fond of, I would say. But because this is we're still working on it. A lot of things, like nothing's set in stone really. So things might change. If there's a better way of handling those sorts of things, we're going to look into it. But yeah. Right. So on to another question from Anonymous. Is there a CLI support for dashboard JSON validation? I can answer this unless somebody else wants to answer it.
Go for it.
I mean, it's in our, it's going to be coming up. I imagine at some point, maybe, or at least an endpoint in the very beginning, to be able to at least be able to validate against. It's something that we're thinking about. I'm not sure if there's been any other updates around that. Maybe Sam or Malcolm, please shut me up if I'm saying something wrong.
No. There's a merged PR. I can't recall if it landed in the Grafana CLI V8 version, but there either is or will presently be a Grafana CLI Q validate command, which you can pass JSON to, and it will try to validate a dashboard. The problem, as I discussed in the presentation bits, is that the schema aren't mature yet. So you'll get false positives or false negatives, right? The thing that we really have to iterate on right now is getting the schema mature. The interesting thing to note about it, and to what Jessica was saying, is that the way that the schema system is designed is if you actually go to look at the implementation of that command in Go, then there's very little. We're essentially just reusing everything. We're essentially just reusing all the code for doing API endpoint validation as we are for using CLI validation. It's a thin layer on top of the schema system. So you can even write your own applications that do Grafana dashboard validation in Go quite easily.
Awesome. I think we only have a few minutes left, so maybe only time for one or two more questions, I think. So yeah, so last top one. And keep in mind, by the way, if your questions are not answered, we will try to get to them eventually. So fear not. But the last question is, what was the hook that we used to integrate with GitHub? And can it be used with local Git?
So what we did, we listen on, we use a Golang WebSocket client to connect to Grafana using the live feature within Grafana 7.3 upwards. And all the demo was of a small piece of code that I put together to show that it's possible. And in the world where everything is possible, then it's possible to talk to Git as well. So I think as Jessica mentioned, we're talking about now. We're going to talk about what products can we make and how do we meet user needs here and so on. So watch this space is probably the answer.
Awesome. Right, I think that means that we're at time, actually. So thank you, everyone, for joining us today. I really hope that you enjoyed the talk as much as we're enjoying working on this. And we'll try and get something out to answer all of these unanswered questions because there's quite a backlog of them at the moment. So I do apologize. But yeah, thank you so much. And I hope that you all enjoy the rest of GrafanaCONline 2021.
Thank you.
Thanks, everyone.
Thank you.
Hello everyone, this is Yashwardhan and welcome to GrafanaCONline. I hope you had a great time till now with all the talks till now. So this talk is going to be about how to set up and visualize synthetic monitors at scale with Grafana Cloud. So moving on, quick intro about me. So I'm Yashwardhan and currently I'm working as a software engineer at Grofers, which is India's one of the most leading e-commerce applications around delivering groceries at a doorstep. Apart from that, I'm also a Linux Foundation's CNCF mentee for the Kyverno project, which is a Kubernetes native policy management engine. And apart from that, I love to read about distributed systems, astrophysics, do open source dev in my free time. And to break the programmatic monotony, I also love to do long distance cycle rides. So before moving on, I would first of all love to give a shout out to all the open source communities out there. So amidst these tough times of COVID, I actually jumped into the whole zone of open source development, especially around cloud native and Kubernetes native organizations. And I absolutely enjoyed that whole period of that. And the amount of love, support, and talent you get acquainted with is just amazing. So shout out to all the folks, all the maintainers out there, maintaining such great open source communities and spreading talent and positivity with everyone, especially in these tough times where everyone is alone in their homes. It's not a tough job. It's a very tough, it's a very tough job to do so. Cool. So let's move on. So speaking of the agenda of this talk, so first of all, I'm going to be covering some theoretical aspects such as what is synthetic monitoring, why do we need it, and I'm going to jump into the theoretical side of explaining what is Grafana synthetic monitoring and plugin and what makes it so cool. And then we'll jump onto the fun part where I'll practically do a hands-on demo of showing how to set up a synthetic monitoring plugin with Grafana from scratch in under 5 minutes and how it's going to give you a fantastic dashboard around it. And finally, I'm going to end with speaking about a few alternatives out there which are there serving solutions around synthetic monitoring. So let's dive in. So speaking of synthetic monitoring, the what's and the whys. So from a very high level standpoint, synthetic monitoring is basically monitoring your application from a user standpoint, right? So you have things like unit testing, integration testing, which actually test the individual functionalities of your code of your application. But at times you need some sort of a monitoring or testing mechanism, which also simulates sort of a user behavior to test that how the application would work or look to an actual user in the world. So these synthetic monitoring checks basically involve high-level API checks, which just ensure the availability and the great performance of our application. So, and it is extremely crucial for large-scale applications, especially the ones which are serving across the world or across some countries, because although your code might be absolutely same across the application which is deployed around the world, but still there can be architectural concerns which might be causing outages or bad performance of an application in, let's say, in US, but not in India, for example. So in those kind of scenarios, these kind of synthetic monitoring checks are the ones which raises the alerts, the alarms to the system administrators to look into these things. And for all these reasons, synthetic monitoring checks serves as a fantastic set of metrics and service level indicators for defining SLAs around availability and performance. So just to give a nice overview of what things can be tracked with synthetic monitoring. So as I give an example, right, application level end-to-end availability. So let's take an example of Amazon.com. For example, I want to set up synthetic monitoring checks for Amazon.com. So this application level end-to-end availability would be some sort of a simulation in which a user enters Amazon.com on their browser. Let's say the user sits in Australia, they enter Amazon.com in their browser and they get a successful response. That can be a kind of like a synthetic monitoring check. Speaking of a service level availability, so for example, this goes a bit more granular from the end-to-end availability check, where let's say Amazon is an e-commerce company and it can have a microservice or a dedicated service or payments, right? So a synthetic monitoring check can actually simulate the checkout behavior or the payment behavior to check that, okay, if that service is available in, let's say, US region or Australia region or Asia region. So that kind of service level checks around performance and availability can also be performed. Speaking of the geographical bottlenecks, so you also want to ensure that across, if your application is serving across the world or across the countries, it's serving in an equivalent manner. Like there is no specific country or region in which the performance is bad or the website is not available due to DNS outages. So those things can be confirmed at a geographical level as well. And finally, infrastructure level availability is also there, where these are the components which are not exactly faced by users, but these components are kind of like the pillars on which our application rests. For example, behind the scenes, our application might be making use of console or vault for configuration management and secrets management. So if any of these services goes down, your application will be halted. So you can define synthetic monitoring checks to ensure the availability and performance of these tools, infallible tools out there, so as to ensure the availability of your application from an indirect standpoint. So moving on, speaking about the Grafana synthetic monitoring plugin. So out there are a lot of great tools around setting up synthetic monitoring checks, but Grafana is one of the, in my opinion, it's one of the very nicest tools to do so because of multiple reasons. So first of all, the ease which comes with it, that you have to just deal with only the GUI, no terminal or code to set up synthetic monitoring checks. You just go to a dashboard, you just go to a Grafana portal, set up the plugin, and just set up the checks. And the good part about these checks is that you can define parity at the level of geography as well. So if you look at the image in front of you, you see these green dots right over this world map. So these green dots actually represent that the synthetic monitoring check in this situation is working perfectly fine for a US citizen or for a European citizen or for an Indian citizen. And it even tracks the latencies associated with your synthetic monitoring checks application, right? And it also gives you a fantastic dashboard automatically with which you can visualize and get really great insights around your synthetic monitoring checks in a very holistic standpoint. And finally, the cost model is really fantastic. It's extremely cheap. First of all, the free tier is really great. And secondly, for this synthetic monitoring plugin, you only pay for the metrics which are being stored. So behind the scenes, all these metrics, right? Behind the scenes, it's storing metrics around the availability and these checks. So these are being stored by Grafana hosted Prometheus and Loki. So those are also very cheap and very cost effective in that standpoint. So that's why it's very cool. And one of the biggest and coolest things about Grafana synthetic monitoring plugin is that you can set up this entire thing in almost 5 minutes. That's it. And I'll actually show you. So let's jump onto the fun aspects. And yeah, let's jump onto the practical side where I'll show how to set up a Grafana synthetic monitoring check direct hands-on. So speaking of the practical aspects, so this is how your Grafana portal is going to look. So do one thing, just simply go over to this gear icon of settings, hover over to this, and go to the plugin section. And all you have to do is just type synthetic monitoring. For me, it's already typed, but yeah, you can just type it and it's going to list down the synthetic monitoring plugin. Just click on it. And there's going to be a button down there of saying enable synthetic monitoring plugin. For my case, it's already enabled, but yeah, it's going to say enable for you, and click on it. And by the way, synthetic monitoring plugin of Grafana makes use of Prometheus data source and Loki data source. And one prerequisite is that they have to be hosted on a Grafana cloud account. They can't be personally hosted. Now, this might sound expensive, but it's not, because the Grafana's free tier is really great. Like, it's way diverse enough to actually, allow you to play around a lot with synthetic monitoring plugin. In fact, that's what I'm doing right now. Awesome. So once you enable this synthetic monitoring plugin, this icon is going to appear on the left navigation drawer of this globe. And you can just simply hover over to this and go to checks. Now, before moving on and setting up a check, I just want to clear one term, which is called probe in this situation. And so basically what are probes? Probes are basically servers or these test runners, which are going to do the hard work, the actual execution of its synthetic monitoring checks. And they're going to be the ones who will get, success or failure from your website, from your application, and report it to Grafana. And then Grafana will plot them accordingly. So those are basically probes. And Grafana Cloud actually provides 13, or I guess a lot of basically public probes, which are categorized by different geographies, like across different regions, for example, Atlanta, North America, and whatnot. But if you want to own your own probe, if you want to own your own server as well, on which the Grafana's synthetic monitoring checks run, you can set up this thing called private probes, which is extremely easy to set up. You just have to feed a Grafana API key and the URL of your Grafana portal and just set up one agent, and that's it. So you can simply check out this documentation of Grafana around private probes. Just Google it. It's very easy to set up. So in this scenario, I'm going to be just showing you how to set up public probes. So yeah, let's just set up a new check. So let's say I'm setting up a check for, let's for the sake of example, let's take I'm setting up a check for Amazon.com. So there are different varieties of check I can set up. Ping, there's a ping check type which checks for ICMP protocol level checks, but we're going to do HTTP level 1. So you can also check set up checks for DNS resolution via this DNS check type. But yeah, in our situation, we're going to go for HTTP. And let's say my job name is, I don't know, like homepage check. It's a random name. You can go with a better convention, but yeah. And I'll just specify the base URL of the application which I'm trying to test. In my example, I'm using Amazon.com. And we can specify the API level parameters as well. So there might be situations where you might have custom query parameters which you want your URL to be attached with. So you can specify them there. In our situation, we don't need them, so that's not a concern. Now comes the probe related configuration. So this asks for the probe location. So I told you about the geographical level parity, right, which synthetic monitoring can perform. So let's take an example. Let's say that I own Amazon.com and Amazon.com runs only in North America. So I would actually, so there is no point setting up a probe or server in India to check whether Amazon.com is running in India or not. That doesn't make sense because my application is dedicated towards North America. So I can actually geographically tell Grafana to set up probes in these locations, like for example, Atlanta, which is a part of North America, Los Angeles, and let's go with New York. So behind, now once I set up this synthetic monitoring check, Grafana will actually set up 3 servers, 3 probes in these individual locations and simulate user behavior from there to actually depict that a user sitting in Atlanta or Los Angeles or New York is going to be able to get what kind of performance or availability. Cool. Now setting up the frequency of this test, let's go with 10 seconds. It's going to run every 10 seconds. And timeout for any API level check, let's keep a healthy one. Let's keep it 1.5 seconds. So any API level call which takes more than 1.5 seconds is going to be registered as a timed out call. Cool. And we can, this configuration is enough, but you can even go further down. Let's say your check is actually performing a post API call. For example, there are situations where you want to synthetic monitor a database. So in those kind of scenarios, you want to perform a write sort of thing. So in that kind of scene, you would have to perform post checks. So you can set up post and provide the request body. That would suffice for the check. But in our situation, it's going to be a get check. And rest, there is scaleless configuration around certificates, authentication around bearer tokens, which you can set. It's all your choice. You can do that. And alerting, of course, there is 2 types of alerting. You can set highly intensive, mediocrely intensive, and low intensive. And this automatically by default sets up a nice set of alerts. So you don't have to, basically calculate on your head that, okay, what kind of alerts would be good for me. Right now, we won't set alerts because we don't need them, but yeah, it's extremely quick. Just go here and Grafana will guide you how to set up alerts. Cool. So we'll just save this thing, this check, and it's ready. Now we'll just quickly go over to this icon of Word, this earth icon, click on it, and automatically see Grafana has spun up a beautiful check for you, a beautiful dashboard for you depicting these checks. Please ignore these metrics. These are the ones which are of my previous previous checks. But I'll just show you the current ones. So if I refresh it, yes, amazing. So you see these 3 green dots. These 3 green dots are actually depicting those locations, Atlanta, New York, and Los Angeles, and are actually depicting that, okay, probes sitting there or users sitting there, what kind of performance will they face when going to Amazon.com. And if you look at this tabulated panel as well of HTTP checks, you can check out the average latency, the average uptime associated with it. It gives you a fantastic panel of HTTP latency as well to give you a trend over a time range of how latency are looking. So that's pretty much it. That's how it looks. And you can, of course, edit the dashboard. You can add panels to it, add alerts to it. Although I'd suggest you should go for automated alerts because they're easy to set up. And well, yeah, they're easy to set up and convenient and more reliable. So I hope the demo was great and intuitive, and I hope you got the point around how to set up synthetic monitoring plugin in just almost under 5 minutes. So speaking of any alternatives out there, well, there are multiple alternatives around setting synthetic monitoring checks. So the first one is AWS CloudWatch Synthetics, and it's a really cool one. So AWS actually provides a managed offering for setting up synthetic monitoring checks for basically for AWS Cloud. But the problem is that it gets really expensive at a larger scale, right? Because the way its cost model works is that it actually costs you per each synthetic monitoring check which happens. So assuming your check is going to be happening at a rate of 15 seconds for 24/7 by 365 days of the year, so it's going to hog up a lot of costs. So that's a slight con of AWS CloudWorks Synthetics. Speaking of KubeHealthy, so KubeHealthy helps you set up Kubernetes native synthetic monitoring checks. So for example, if you want to have synthetic monitoring checks over a cluster to ensure that a user at any time is able to create a deployment or to create a pod, or the DNS across Kubernetes cluster is working perfectly fine. So those kind of checks can be established via KubeHealthy. And honestly, I've used it and I've even contributed to it. So it's a really great project. You can check it out. Apart from that, there's Black Box Exporter. So Black Box Exporter is basically the whole fundamental pillar on which this Grafana synthetic monitoring plugin lies on. So Grafana synthetic monitoring plugin is kind of like a wrapper over this Black Box Exporter. So you can of course Google and check it out. It's a pretty interesting project. And speaking of doing something inconvenient, well, you can obviously write on cron jobs if your use case is extremely custom and very, customized according to your company or a team. It's a bit inconvenient, but yeah, at some situations, it might be the most quick thing to do. And there are other tools, countless tools like New Relic, Datadog, which provide capabilities to set up synthetic monitoring checks. So I hope the talk was great, and I hope you understood the points. And of course, you can reach out to me on any of my social media handles, which are given below. And yeah, I would love to connect with you. And yeah, I hope you had a great time. Thank you.
Yeah, hi everyone. So I guess this is the Q&A session. So I'm seeing 4 questions as of now. Okay, I guess there are 5. So I'll just first of all encounter this first question, which asks that does synthetic monitoring work with all panels? So basically, Grafana synthetic monitoring plugin gives you a ready-made dashboard, but of course you can edit it as well. So you can augment the dashboard with your own stats panel, for example, if you want to use it out and set alerts on the basis of that. So yeah, that kind of augmentation is absolutely possible around that. And I mean, it depends on how have you set up the synthetic monitoring checks and accordingly, tweak them and get the metrics and yeah, just basically spin up panels and yeah, make use of them and make and set up alerts over them. So that's one. Secondly, the second question is that is it possible or planned to integrate more complex E2E tests with emulating user actions such as filling forms, clicking on buttons, etc. So yes, of course, that is possible because on the Grafana synthetic monitoring plugin, basically the checks are defined. So there are 4 types of checks, right? Ping check, this thing DNS level check for DNS lookups, TCP level checks, and HTTP level checks. So anything basically associated which can be done through a REST API endpoint can be done. So for example, filling a form can be kind of like a post request, or clicking of buttons can simulate a get request or a post or a put request. So anything which is basically encapsulated behind a REST API endpoint can be done by a synthetic monitoring endpoint. So I hope that answers the question. The third question is that how do you make sure you aren't going over the free plan limit? So basically, Grafana Cloud provides basically many ways to alert you regarding you're exhausting your series. So regarding the free tier for Prometheus, I guess it provides 10,000 or 15,000 time series as free of cost. But you can of course so in the billing dashboard you can actually set up billing alerts around basically how much billable logs or billable metrics or billable series have you consumed. So accordingly you can set up alerts. Also from my experience, Grafana also sends you automated mails around how close you are about to get exhausted of your trial period. So that's also one thing. So I hope that answers the question. Finally, the question is that do you need to set up separate probes for each type of check, or can one probe do multiple check types? So one probe can do multiple check types. Basically, the whole idea of probe is to basically introduce geographical parity between different nodes. So for example, if I want to execute 5 synthetic monitoring checks from, let's say, US to simulate how a user sitting in US would face the use of website, so that I can do that. And I can set up my private probe as well, which is the one which I like, the whole server, the probe server. I can set it up manually as a private probe and yeah, run multiple checks through it. So just at the time of configuring every check, you can actually choose the same probe every time. So that's the choice. Now, can you elaborate on what situations where a custom cron job might make more sense? So that's a good question. So that's also, so right now, if I talk about Grafana synthetic monitoring plugin, so it has a slight hiccup where basically as one check cannot, basically simulate multiple API calls. So this is one of the issues where my personal company also faced this concern. For example, we were basically trying to make one synthetic monitoring check, which was behind the scenes relying on 5 successful API calls. And as Grafana synthetic monitoring plugin didn't support that, so we had to write a custom cron job for that. So that was a scenario. So very custom scenario. And in which database the test results are stored. So basically the test results are stored on the storage backends which are hosted on Grafana Cloud. So they are stored on both Prometheus database, which is a time series database, and the Loki database, which is also hosted on Grafana Z. So you don't have to deal with the scaling the infra side of it. So I hope that answers the question. And I guess I'm not seeing any other question. So yeah. So so your question is for complex E2E tests, I mean fully emulating user actions in the browser. So I'm not exactly aware because again, I mean like anything which can be simulated through an API can be done. So for example, this whole complex test can be triggered by an API point. For example, whenever a post trigger is sent through that API call, it's going to be triggered. So I guess you can perform that as soon as it's exposed by an API endpoint. So I guess that's pretty much it. If you have any other questions, feel free to reach out to me on the Grafana Slack and the observability, the GrafanaCon's Slack channel. Yeah, and thanks to be here and thanks for checking my talk out. Thank you.
Hello everyone, my name is Dinesh Chala and I am here today to talk to you about the Romanian Economic Impact Monitor. This is a COVID-19 information site and it is built upon a Grafana dashboard. We are operating the project out of the Babeș-Bolyai University in Cluj-Napoca, Romania, and the Faculty of Economics and Business Administration. We have a team of 6. We have Levente Sas, myself, Csaba Bálint, Béla Gergely Rácz, Otto Csiki, and Bálint Zsolt Nagy on the team, which makes it 5 economists and a data scientist. So I am going to show you some bits of code and how our dashboard operates, but please bear in mind that none of us are actually software engineers. So it might be really not, it might work, but it's going to be really the band-aid method in a lot of places. But we did manage to make it work, and we have been operating for about a year now. We are one of the most visited COVID information sites in the country, and we have been featured sort of on everywhere from the regional web pages to national TV. We use Grafana for dashboarding and not monitoring, well, also for monitoring, but specifically we are using Grafana to help with the layout. Well, of course, it's that's going to be done by React, most of it in the background. We are using a 7.0 Grafana version. I will tell you a little bit in a while why is that. And we did try in the beginning of the pandemic. So in Romania, the pandemic hit in March 2020, and in the beginning there was complete chaos. It was very difficult to find information, especially reliable information, and the government was just publishing, in the beginning it was actually PDFs, but then later on these plain text bulletins about the evolution of the numbers. And we really wanted to have a common dashboard where the public can go and inform itself. And our reasoning was sort of coming from the role of the university as a public institution during times of crisis. Perhaps the best role it can take is that of informing the public. So this is where we were coming from, and we did check out quite a few solutions, quite a few alternatives. We did try to code up the entire site in D3.js. Of course, that's always an option. But then the amount of work necessary to keep updating that, and the work that would have been needed to be put in continuously, just sort of voted against it. We also tried some Grafana competitors. We tried Superset. We also tried Anaconda Dash, Anaconda Panel, and Plotly Dash. But eventually we settled on using Grafana. So today, I thought I will try to go through 3 sections. Namely, I will try to show you the dashboard. Well, of course, you've seen many of the Grafana dashboards, so perhaps this is not so interesting. Ours is sort of a little bit customized, so it might be interesting from that perspective. And then I'm going to show you the code and the services that we are aligning next to Grafana in order to operate the Economic Impact Monitor. And then I am going to show you a little bit of the plumbing. So how did we get to the customizations that we have? So right away, I will start with the dashboard then. So this is how our landing page looks like. We are operating on Grafana 7.0, and in the front page, it's a one-pager, and on the front page we are showing you 12 single stat panels, and then actually this is the old single stat panel because we wanted the graphs to the background lines to stretch over the entire area of the panel. And then here we are just trying to combine the current pandemic numbers with the larger, longer term economic context. And then you can see that our dashboard is sort of fairly customized. We operate 3 languages. So of course our main language would be Romanian, and then we also operate a Hungarian language version. But I'm going to be showing you the English language version now. And then we also operate 2 themes. So we do have a dark theme and a light theme as well. So what you can see is that we are using the dashboard in kiosk mode, right? So we have removed the side panel as well as the nav bar, and it's also in authentication less mode. And we have replaced the nav bar with our custom nav bar because our site is sectioned into a few, depending on what topical areas we are trying to put the pandemic numbers in, what context we are trying to show them in. We have quite a few sections that are constructed as Grafana rows, right? So they are like drawers. And in terms of the panels that we use, well, you can see that we are also operating a custom theme. This is just accomplished with a combination of a plugin called Boom Theme and also a custom CSS. In the third part, in the plumbing part, I will tell you a little bit about how is the custom theme loaded onto the site. What you can see is that on top of the single stat panels, most of the rest of our panels are basically split into 3 categories. We use built-in Grafana plugins, such as these line plots over here, or even this heat map or carpet plot over here. We use some community plugins as well. And then we actually don't use currently any of our custom plugins, but we do have some custom plugins under construction. So for example, this map is effectively just an iframe, so it's just an embedded map. This shows the pandemic numbers, the incidence rate of the pandemic on a settlement level, and then these are the settlements of the country of Romania. And then if I look at this in the background, this is actually operated through a video panel. Why not an Ajax panel? Of course, this would be, or even a simple HTML embed, since it's just an iframe. You might ask very validly, right? So the reason that we opted for a video panel is because in the video panel we can embed iframes, and we issued a pull request to the developer of the video panel to insert an HTML attribute in the iframe tag, and namely allow geolocation. Because we do have a search box here, and then if our users want to know what are the pandemic rates where they are, they will need to click on this Find My Location button, and then because this is an iframe, this needs to be propagated up to our host. And then in the Ajax panel, there's no way to set custom attributes on the iframe. In terms of the rest of the panels, it's really just we just have some line plots showing the evolution of the pandemic. We show we have some embeds of our Facebook page. We show the news where we have appeared, and then we try to put the pandemic into various kinds of contexts. So each of these sections, it's a different context for the pandemic. So for example, this is the global context, and then we just use annotations in order to create events and then superimpose them over the pandemic numbers. And then typically we have quite a few sections where we have the evolution of the pandemic numbers superimposed with annotations over them, and then we show the annotations in a table as well. Perhaps, so please do go ahead and check it out. I'll put a link at the end of the presentation, but perhaps one of the interesting sections is that we track we bring in the Google mobility numbers, so we track how did mobility change over the pandemic. So March 2020, pretty much neutral, and then 1 month later, in April, the whole country is in red. Some recovery over the summer, and then second wave over the winter, and then now some recovery presently. And then this does exist on the level of each of the counties. So these are the administrative units of Romania, and also several industrial sectors. And perhaps another interesting part is the real estate market. So we track the evolution of house prices with regards to the 2008 housing bubble. So house prices really crashed in 2008, whereas now they are sort of staying quite steady. And then we just show the 5 largest cities of the country. So these maps, these crawlerpad maps, and then these scatter maps, again, these are done with a custom HTML embed. So we do operate an HTML server where we host our custom visualizations, and these are actually done in D3.js. The very first map was done in Mapbox GL. So as you reach the bottom of the site, of course, we do show all of our data sources, we show our team, and we put a link to our data repository as well. So our repository is under Dennis Data/ROEM, so that's Romanian Economic Impact Monitor. And we do have a wiki page where we try to explain the steps for you to start your own Romanian Economic Impact Monitor style site if you really wanted to. What I want to do during this talk is to show you a little bit about the services that we use in order to support Grafana. We started with 6.7, and then we upgraded, I believe, just after last year's conference to 7.0, and then we have an outstanding milestone for upgrading for 8.0, which it might have been out already, or it's going to come out, as far as I understand, during the conference. This is actually quite a large milestone because I'm going to show you here, we are matching that up with upgrading our InfluxDB to InfluxDB 2.0 as well. So currently our main database is an InfluxDB, and we are operating an InfluxDB 1.8. And the reason why this is quite a significant milestone is because we would need to transition our InfluxQL queries to Flux queries in order to ensure sort of future scalability. So we do have an outstanding milestone for that as well. We have a minor sort of dictionary in the Google Sheet to make sure that the site's content is delivered multilingually. So we only edit one of the sites, and then all the content is delivered automatically through Grafana's HTTP API to replicate it across all the dashboards. So there are 6 dashboards in total, right? So we have the Romanian, Hungarian, and the English, and then both the dark and the light theme versions from both of these. So our main plumbing mechanism through which we make sure that the data gets into InfluxDB and then the Grafana dashboard gets updated is Jupyter. We just run a Jupyter Lab server, and then we interact with HTTP APIs in the backend, both with the Grafana as well as with the InfluxDB. We also use separate HTTP server, so an Apache HTTP server to run our custom visualizations. And then, as I said, most of our custom visualizations are in D3 Plus, or some of the more complicated maps are in Mapbox GL. And then to make sure that everything is served from HTTPS, we use traffic. So I'm going to show you the Docker Compose file. All of our services are Dockerized. They run from their own containers. And then this is how our Docker Compose file looks like. So we have, of course, we have the traffic service, and then we have a 7.0 Grafana running. The environment variables that we use are just anonymous authentication and allow embedding, so that we're using kiosk mode without the login screen showing up, and that's it really. And then we have our Influx container, we have our Jupyter container, and then the HTTP Apache server. So I think if you git clone into this repository and then just Docker Compose up, of course, you have to go through some of the prerequisites that we describe in our wiki. You should be able to set up your own economic impact monitor on this tech stack that I have just discussed. We also operate automatic data updates. So you see that the latest commit was done just a few minutes ago by our ROIM bot. So that's the Romanian Economic Impact bot. And then technically the dashboard itself would not need to be strictly updated with every new data release. But we do show in the landing page, if you see here, we do show the number of days that have passed, and then the number since the beginning of the pandemic in Romania, and also the number of active cases. And what we need to do is we need to go into the Grafana backend through Jupyter and then through the HTTP Grafana API, and then we just update the content of this panel. And then we also show sort of like last updated times, and then on each of the panels we have an info bubble, and then in the info bubble we just make sure that the update times are reflected on the dashboard. Okay, so this is about the code part, and then now I will talk to you about the plumbing. As I've mentioned in the code section, we don't actually use any kind of Python plugin to interact with Grafana. We just use the simple HTTP requests panel, and then we connect to the Grafana container in the backend, so throughout the Docker network. So we have a custom CSS, and then what we do is we overwrite Grafana operates on two CSS files, right? The dark and the light CSS, and then what we do is we overwrite these CSS files in the build folder. So it's not necessarily the most elegant way of doing it. So what we could do, of course, we could build our own Grafana, but because of time constraints and because this just works so far, what we actually do is we go into the public folder, so after the build, and then we look at the build string of the CSS there, and then we overwrite that particular CSS. So we copy everything that's in there, and then we add some customizations to it. And with that, I will wrap up. Thank you very much for your attention. Please do go and check out our site. It's at econ.ubbcluj/coronavirus. And you can check me out at Twitter as well as GitHub at CSALADNES. If you have any questions, I'm happy to take some questions either now or later on over Twitter. Thank you very much. Enjoy the rest of the Grafana Conference 2021.
Hello, everyone. It was really great talking to you about the Romanian Economic Impact Monitor. And thanks a lot. I looked at some of the comments on Slido and also some of the comments on Slack. I'll just take a few. So Alexa is asking if we used some sort of caching to improve performance. We did not on top of the default Grafana caching, but we did notice, so as I said, we are on 7.0 now. Of course, we want to transition to 8.0, but we started with 6.7, and already from 6.7 to 7, the built-in Grafana caching improved. So as you say, perhaps in 8 is going to improve even further. So this is a trick here, because the caching is only for the UI, and it's clearly the first load is about 10 seconds, and then the second load is about a second. So it's much quicker on the second load. So it's a really great question. Somebody else is asking if we used Grafana for other research projects, and here what I want to say is in Cluj-Napoca, the technical at the Babes University and the Faculty of Business Administration and Economics, I teach a course about data visualization, and we do have a subject called Integrated Systems, which is basically about Grafana. And throughout the semester, you would be quite amazed about how complex of a dashboard can the students put together from scratch. So yeah, esports, cryptocurrencies are recurring topics. Perhaps now the evolution of the Euro 2020 football games, but there's just a plethora of topics, and it's quite interesting to see, as I said, that they use it specifically for data visualization rather than monitoring. But some of the students do set up like live monitoring sites, and most of the time we try to couple it with some time series based database, InfluxDB or even MySQL most of the time. Did any of the data, I think this is the last question I take, did any of the data surprise our team? Yes, it did actually. Once in a while, we managed to get to talk about our dashboard on national TV. And I was quite surprised that the TV, this might be something particular to Romania, but whenever we appeared on TV, was the visitor numbers just jumped so much more. Even when we appeared on national, like very large portals, the TV just brought like a 10x increase in visitors. So that was quite interesting from an operational perspective of the site. And then the data related to COVID, perhaps the most surprising was the mobility numbers. The mobility numbers just drastically dropped. We had about a 90% drop during the Easter holidays and the lockdowns, but by now they have recovered to pre-pandemic levels. I think that's all I can take today. Thanks a lot for listening to my talk. If you have any further questions, please do let me know on the Slack channel, on the Grafana Slack. I'll be ready to answer anything you might have, and enjoy the rest of the conference. Thanks a lot.
Hello, my name is Roland Higgins, and I'm going to present the Grafana deployment on board the Sofia Airborne Observatory. So, as I said, I'm a researcher at the University of Cologne, and along with my colleague Christoph Buchbinder, we've deployed Grafana on board Sofia, the Sofia Airborne Observatory. Yeah, just to get it out of the way, I couldn't have survived the past year without the family and kids, obviously, and I just want to say a big hooray for flexible working hours, and homeschooling is the joy everyone should have in their life. Yeah, so to get through the agenda, so I kind of break it down to a what, why, how airborne astronomy. Then I go through the different instruments and subsystems that you have on board an airborne observatory. And then I get into what's the Grafana usage, what a typical flight looks like, and where Grafana helps with a couple of real world examples. So yeah, airborne astronomy has been around for a while. It started in the 60s. There was a Learjet, then it moved on to the Khyber Observatory, which was a converted military transport, and then the next generation then was Sofia. So Sofia is a converted 747 SP, which was originally built for Pan Am in 1977. This is based out of Palmdale, and it's a joint project between the German Space Agency and NASA. So it's got a 2.7 meter telescope mounted in the rear with a retractable door. So here's on the right hand side. And then this region here is pressurized like a conventional aircraft, and then obviously to see through the atmosphere, the telescope cavity is unpressurized. So then a typical observation is you have the telescope operator sitting here who operates the telescope, obviously, and then you've got the instrument team sits here, which is normally where myself and my colleagues sit. And then you have the mission director, who's kind of the captain of the ship, and he's the one who orchestrates the whole operation. And then, of course, you have the most important people on the aircraft, the pilots, sit up the front like a conventional aircraft. Yeah, so the nice thing about airborne astronomy is that you have this, you get above the atmosphere, so you're similar to a satellite, but you also have the fact that you can return home and you can swap out different instruments. So it gives you a flexibility that you don't have with a satellite system. And then with that, you can also have faster development of instruments. That again is a problem with satellites, where you don't normally fly the state-of-the-art system. And that's the advantage of Sofia, is it's really a good test bed for new types of instruments and receivers and detectors. And that's something that we make full use of. So then to go through the instruments, so there's a range of instruments then that focus on different scientific use cases. And for the great instrument, we're in this plot is showing the spectral resolving power. So how fine can you measure the photon frequency? And then at the bottom here is the actual energy level that you can detect. So GREAT is in this niche market where we're a spectrometer, so we get this very fine frequency resolution, and with that we get a fine velocity resolution of the gas that we're measuring. Then there's other camera instruments that are sensitive to polarization, and they have their own niche use cases, and you can see the overlap with other ground-based instruments here, for example, the future-launched JWST. Yeah, so just to return to that point of why do you do airborne astronomy? And the problem is the atmosphere is that above a certain frequency range in the atmosphere absorbs the radiation, and you can't observe frequencies from astronomical sources. You have to go above the atmosphere to access certain frequencies. And with that, there's different physics available that you can't access from a conventional ground-based observatory. So this plot here gives you an idea of the transmission. So for my amusement, I put Cologne at sea level at the bottom here. You can see Cologne from 500 to 5,000 gigahertz has zero transmission on a normal day. And then as you go towards higher mountains in Chile, for example, the CCAT observatory, you start to get windows opening in the atmosphere, and people build dedicated instruments to focus on these instruments, and even right up here to 2 terahertz. But you can see these will be the best days at those sites. But with Sofia, you get in your 747, you fly up to 11,000 meters, and then you get access to these frequencies that don't reach the ground. It isn't 100% transparent. There are bands of atmosphere at higher altitudes that still block irradiation, but it's as good as space at certain frequencies. And I've just highlighted two of the key molecules that we have built this instrument for. Yeah, so then so as I said, the upgrade is a spectrometer. So what does the data look like from a spectrometer then? So on the left hand, I have a very nice Hubble image showing showing the Orion Bar region, which is a famous, very pretty region, one of the iconic Hubble images. And then on the right-hand side, I show our not so exciting spectra, which shows what we've done is we're looking at a given region, and then we can split out the light, and from that then we can get an idea, kind of a tomography of the gas in that line of sight. But when you put this together into a larger map, then so you take all those single spectra, you can build what's called a velocity cube. So you have an XY spatial direction, and you have a velocity direction. And with that, then you can disentangle the kinematics of these regions that wouldn't be possible with the Hubble image directly. So that's the nice thing about these heterodyne systems is you can get this sort of velocity cube here. And from that, you can see there's a whole lot more going on than just the 2D projection that you had with the Hubble image. And this is we should bear in mind this is 14 flights and 42 hours of observation, so it's not easy to get these large images either. In the bottom right, then I just show an example of an iconic Horsehead Nebula Hubble image, and then on the right hand side is the ionized carbon, and there you can see with the different colors you're looking at the different velocity contributions to that region, and you can see that the top of the head of the horse is quite different to the body and that surrounding the surrounding material. So this is the type of physics then you can disentangle with heterodyne spectroscopy. But yeah, enough with the science. Then let's get into the Grafana usage. So one of the problems we had initially was that we had a lot of different subsystems, all with their own different logging and graphing systems, and to bring all that data together was becoming problematic. So we made this. To see what was on the market, we came across InfluxDB in combination with Grafana, and we gradually progressed over to that in the last 2 to 3 years. So on the aircraft, then you have multiple subsystems that we have to observe. So there's the aircraft itself, there's the instrument, there's the upgrade instrument mounted on the instrument flange. Then you have the telescope, you have the cryo cooler that keeps the instrument cool. And then in addition to that, you have the data quality. So the data is coming out and it's getting monitored for data quality, and that's all pumped into the InfluxDB. And of course, we have the classic Grafana use case is the IT infrastructure. So all our network switches, disk drives, computer load is an important thing. Sometimes computers there's too much going on and they can tend to back up. So that's something we have to keep an eye on. All that gets pumped into Grafana, and then we bring it up in dashboards. So you're looking at about a 2 GB per flight then data load. So nothing crazy by IT standards. Yeah, so what does a typical flight look like then? So here is using the world map plugin in Grafana, we're able to overplot the actual position of the aircraft onto a map. And then on the bottom left here, you have an image of the altitude during a typical flight. So here we're at sea level in Cologne, take off, fly out west over Ireland, and then come back and land back in Cologne. Then on the top right, and more importantly on the right-hand side here is a time lapse. I should reiterate, this is a time lapse. This isn't the real-time movement of the telescope. The telescope moves not quite as jerky, or it moves a lot smoother, but it gives you an idea of the sort of range of motion that the telescope goes through. And it looks like in this GIF here, we're doing a classic, we're measuring an on source, then measuring an off source, and we're moving back between those two positions, which you can see here in this leg, for example. And then here's so we had a typical flight. This is a typical flight series. And so you install your instrument and you observe. In this case, we observed maybe 12 or 13 flights in a row at Cologne. And you get an idea then, depending on which source we're observing, we fly in different directions. So we look out we can get the correct azimuth for that source. This is an overview of the telescope state and again, the altitude. So always trying to get above 42,000 feet. Yeah, so then to get onto the data quality. So this was kind of one of the main goals of this system, was to get the end product is the data, and we want to have the best data quality. And one of the issues is you don't get great data quality, and then you want to correlate that with something that happened on the aircraft, or at least learn a lesson so that you can fix that one going forward. Here is a typical example of a flight where we're observing a NGC 3627, and you can see that what we're doing is we have different metrics to follow the data quality, and one is the RMS, just the root mean squared sum of the spectra, and that gives you an idea of the noise level on the spectra. And if the noise level is above a certain threshold, then you know you're having some sort of baseline issue. Ideally, this plot here should be flat, but you have these instrument effects that come in. And sometimes if you have a broad line emission source, these instrument effects can be confused with astronomical emission, and yeah, it can lead to confusion in the scientific interpretation. So here's an example for where we're monitoring the RMS, and then we just see it's kind of a bit ratty. and then it just settles down for some reason. And this is the type of thing then that you would follow up with in flight and see, what did we do? Did we change the state of the receiver? Did the weather change? Did we climb? And these are the types of things that we now with Grafana, we can start to correlate with different states in the system. So here's a classic example is the climbing. So we're flying along and the pilots ask us, do we want to climb? And what happens is during a climb is that we go higher up into the atmosphere. So then the transparency of the atmosphere, because we get higher up out of the soup, with the transmission of the atmosphere goes down, and that means that we get better transmission. But if we're observing during that period, it can lead to a sort of instability in the system. And this we can directly monitor here then in our total power monitor. So we look at the response of the mixer, of the detector, and then we can see clearly. Here's the classic, what we did to describe this timeline is we observe an internal cold load and a hot load, and then we observe the sky. And what you see here is the purple is the altitude climb. So we're cruising along, then we start to climb. And what you see immediately is you see the power of the detected power in the detector starts to go down, which means that the atmosphere has become more transparent, which is the goal, but it means that during that period, you might potentially have some calibration issues. And what's interesting is at the other frequency, which is at a lower frequency, the 1.9 terahertz, you don't see that same effect. And it just shows you that different parts of the atmosphere react differently depending on the outside conditions. But this is a nice example of overplotting the altitude from the aircraft with the output from the receiver, and that before wasn't that easy to do. The next problem for us is this radio interference during the flight. So one of the things we have, this again on the top left is showing a classic spectra where we have a broad emission here. This is the lower LMC, large magnetic cloud. And what you have here is you have this Bluetooth RFI. So Bluetooth starts to bake into our spectra as well. And that's something that we have to monitor during flight because again, it can manifest itself depending on how it comes in as an astronomical signal. And trying to catch that isn't that easy because one of the things we were doing before is just taking the RMS over the entire spectra, which is here on the top right. But recently we started to narrow the RMS to particular channels, particular ranges in the spectra, and then we can start to see clear signatures of radio interference. This is on the bottom right. So the top right here is an average, is the RMS over the entire spectra. And then if we focus on the Bluetooth region, you can really see the pixel light up then when Bluetooth is aboard. And then what you would do is you would ask the mission director, we make an announcement, and everyone checks their laptops, smartphones, headphones, everything does the Bluetooth off, and then we try and go on. It's very hard it's a constant problem for us, so we just have to avoid it mainly. So then just to go into the more hardcore subsystems, the cryo cooler, for example, is an industrial system with a Modbus interface. That's something we recently ingested, and this has been useful for debugging on the flight. Before we just had an industrial Siemens touchscreen display that was mounted somewhere else in the aircraft. Now anyone can pull it up in the browser and we can monitor the cryo cooler, which has been useful. And the next one then is just the low level instrument temperature monitoring. So the temperature has to be kept at the detector, where the detectors are mounted at 4 Kelvin, and this is something that we monitor during the flight as well. But it's normally not a problem, but at least if you think it's an issue, you can bring up this dashboard. Yeah, so what's next then? So one of the things, as I was showing there with the RFI example, is one of the things we would like to have is that we would like, the idea is maybe to do it via a plugin, is that you could click on a data point and you could bring up more data, but like an actual data product on that or an image or something like that. And that's something I haven't found in the current plugin ecosystem, but the plugin interface seems, we might move forward working with that. The next is then we're not using the full functionality of Grafana. So again, we're just novice users in comparison with some of the power users, but using the alerting system more would be useful during flight to bring people's attention to certain issues potentially. And then our main goal is maybe to develop an interactive reduction pipeline so we can make changes on the flight based on the time series data from Grafana. So again, that'll involve using plugins and potentially the AJAX callback to make some changes in the system. So then to summarize, yeah, as I've hopefully demonstrated, Grafana helps the astronomers streamline the data display and visualization. It allows us to correlate data quality issues with outside data sources. It allows for quick comparison with other parameters that you wouldn't normally have in your raw astronomical product, because normally the raw astronomical product is just focused on can you calibrate the data, but what these outside influences are and the high time resolution we have in Grafana is a useful addition. So, and there is a general trend in the astronomy, and I can name 3 observatories here that are moving to a Grafana-based system for system-wide monitoring. So this is on the ground-based telescopes where you have a lot more infrastructure than, like, as well as the telescope, you have weather stations, generators, IT infrastructure, and also personnel monitoring at extreme altitudes. So this is the type of world that Grafana opens up for astronomers, and it's definitely been a big step up for us, and has made our lives a lot easier on the flights. And I'll close it out there, and I'll say thank you for your attention, and if you have any questions, now's the time.
Hey guys, hope you enjoyed the talk. Thanks for the questions there. I see a couple of questions come in. I can try and answer them. So, yeah, starting from the easiest one, how many people are on board Sophia at any one time? There's a core crew of, top of my head, the 2 pilots, flight engineer, 2 mission directors, 5, 2 telescope operators, 7, and then depending on which instrument, 3 to 5 instrument operators. So maybe 12 would be the basic requirement, and then depending on now during COVID it's really cut down because we want to minimize the amount of people on the flight, but there's a lot of public outreach work. It's a really good platform for public outreach, and there is this teacher public outreach aspect where we bring high school teachers on board from Germany and the US. So when those guys are on board, then there would be considerable, there'd be 4 teachers and 4 support people, but it can be anything. I've been on flights with 40 people on board, depending on VIPs and so on. Sometimes when we go to New Zealand, we bring some local dignitaries on board. So it can be anything from a base crew of 12 up to, I think, 40 is the maximum capacity. And yeah, then you need to keep the coffee to be running out quick with that. And then, so more questions. Yeah, so there's another one. What's the hardest data to collect on the aircraft? And that's probably the Sophia internal system. It's called MCCS, and that's a custom-built system, and we have to go over Telnet and subscribe. So it's not quite a standard system. You have to log in, and you want to be careful you don't have too many sessions open. So that one is probably the most tricky to subscribe to, and also you don't want to over subscribe to that system because you can potentially cause an additional load that can bring that system down. But the rest of the systems, like the standard industrial systems and our own internal systems, are Modbus or UDP level, and then the computers, of course, would be the easiest system to poll to. Next question was, do you have any desire to bring this type to other parts of aerospace, perhaps other areas of NASA? If people want to collaborate with us, they're welcome to join. We're happy to share our code. I think there is a movement inside the aircraft industry, and there's a big commercial market for that with Palantir, I think, if I'm saying it correctly. They're a big industrial company that's getting into that data science thing. And I think that data, if you get the aircraft, especially the aircraft maintenance aspect, it's very useful data that Airbus and Boeing keep quite close to their hearts. So open source in the aerospace, I don't think go hand in hand. But for these NASA missions, I'm sure the NASA guys, if they find a better system for making displays, I'm sure they'd be keen to adapt it. So if anyone wants any support, they're welcome to reach out. Is there any interest in discoveries during your time working on Sophia? Yeah, there's Sophia. So there's another question about, do we make the dashboards publicly available? And right now, as I said in the talk, we're an instrument team, so we're just a small part of the bigger NASA project. And NASA have a very good public outreach Facebook page and their webpage. And there they show, for example, flight plans like I showed there, and they also show a lot of the discoveries. So, for example, I showed that rotating cube. And that's the biggest map ever made of that ionized carbon molecule. We recently published a paper on that where we compared it to a previous Herschel Space Observatory map. But that's been really exciting, and that was a Nature paper where we did figure out how large stars, massive stars, can impinge star formation around themselves because they really push out. They don't give the material time to settle. So there is a lot of new discoveries coming up in the Hawk Plus, another instrument looking at magnetic fields. And if you go to the Sophia NASA website, they have a really good breakdown of these, and they're constantly updating with new papers that come in there. Yeah, the Modbus. Yeah, that was the scene. What was the question? How do you use Modbus again? How did you? So I used the Pi Modbus, an open source Python Modbus application, and it was the Siemens HDMI. I'm not a Modbus expert. I just had the protocol, but I was talking to a Siemens PLC behind that. Yeah, and I think I got through all the questions. But yeah, thanks for your time and thanks for the interest. Appreciate the enthusiasm there, and I'm happy to share my experiences. And kudos to the Grafana developers and also InfluxDB for making these tools so readily available. And yeah, if you have any other questions, you can get my email there and drop me an email if you're interested in collaborating or if you want any more information. And I'll leave it there. Okay, guys, have a nice evening.
I'm Boris Delovich, and Today I'm going to discuss with you our presentation that actually would be about observability. And we call this observability 360-degree. So, but first let me introduce myself. I'm head of observability and event management at KKR. And the reason why I have been hired just to build up a solid observability platform that can be used by company to acquire all metrics, to use these metrics, and based on this information, make business more efficient. So we're not going to discuss something that is completely unique. I'm pretty sure what I'm going to discuss right now with you is going to be what you well know at some degree, but the combination, the steps, the stages, and the general approach, this is what I hope would make some sense and can be useful for many of you, especially for people who work for industries where security is a top priority, where the regulation is important. And let's start at some point. So again, I'm Boris, and I'm working at KKR, and my role is to build up observability platform. So before going to discuss all small details, probably it makes sense just to refresh our memory and remember about what's observability. And according to Aurelia, I'm pretty sure you know this stuff. It's a combination of collection of different metrics or objects, logs and traces, and that have to be saved under one special location, central location, and later can be used for future analysis. And this is general approach for observability platform, at least for many, many years back. What people usually don't mention, there is something else. There is another pillar, if you wish, that for some reason nobody tried to consider as a part of observability platform, but this is about notification events. Events management, this is very important part of this activity, because number one, you have to ask yourself why you try to build this platform. What are the reasons? And the reasons just to improve business efficiency, as I mentioned. And one of the way to do this by to deploying appropriate notification channels, processes, and minimize downtime, improve availability, accuracy. So for this reason, when you collect all this data and when you do brief analysis and when you introduce notification, finally you create new level of metrics, which is in general business metrics. And that is probably the most important part for all business, for business community. In your case, they would like to know upfront how much time they spend to acknowledge any problem and how much time they spend to fix the problem. And definitely they desperate to see improvement when the acknowledgement is going to drop down time, and when time for repair is going also to be minimal up to some point. And in this case, they can say, yes, our systems, our interfaces, our business definitely have been improved because of observability help. So in this case, on this slide, you can see all this subject that I just mentioned. And besides, it's very important as there service level indicators and service level objects. This is a part of general observability approach. KPIs, in this case, notification events, such as mean time to acknowledge and repair, can be compared to SLA. For example, if your business has SLA 15 minutes to recover from any kind of issue, so these KPIs can be extremely important for you to monitor and compare with your SLA. And that would be the final goal and explanation why observability platform is here. But now let's try to figure out how we're going to approach and build up this platform. So there is some things or some criteria that must be applied to observability platform. At least it would make it more solid and more mature. One is naturally everything should be collected under one umbrella, and it should be flexible enough to collect data from various sites, applications, by using various APIs, interfaces, addresses. So it should be flexible and give you ability to collect data across all environment. Of course, same story with notification process. You would try to build up one single point or focal point of collection, and where you would exist the same alert, escalation, and notification processes. Everything should sit on the same big umbrella, because it definitely would affect your ability to manage efficiently this observability platform. Another very important criteria is the security. Due to compliance and cybersecurity requirements, and for many customers, such as government or financial industry customers, it's a must-to-be criteria. It's very important so your observability platform would meet this expectation, and you and your platform would be secure enough to provide this this service. Scalability, naturally. If you're just doing something for small environment, this is one story. If you're doing this for a large company and you plan to collect millions and millions metrics, in this case, definitely you have to start to think about scalability ahead of time when you're going to meet those problems, degradation due to limit of your resources. And finally, reliability. When I said reliable, of course, people would say reliable, availability, available. But in general, you try to minimize time, downtime, because of problems and because of any maintenance or upgrades. For business, after all, it doesn't matter. Business definitely would like to have this software or applications available 24/7. So naturally, you try to avoid any situation where it's down due to some issues, but you also would try to minimize downtime due to any maintenance task, right? So saying this, I will start to review a couple of different applications and platforms and products. And if you look on Grafana and Prometheus, you definitely will see so it's capable to acquire many different sources. And especially in case of Prometheus, it has ability to work practically with any possible data source. Besides, it's a partially open source, and for this reason, it's naturally give you ability to extend this software and practically extract data from any available data sources I just mentioned. So in this case, you can see general sources that we would like to collect. Of course, we have something else, but I just give you some examples that show you so what you're capable to extract data by using Prometheus from what parts of this stuff. So another part is event management. As I mentioned, we try to treat this as a single point or focal point, as a platform that would collect all data in one place and would manage all notifications, escalations by using the same solution. And this is, by the way, would be applied and for system metrics or indicators and for business metrics or indicators, naturally for applications too. Everything is coming to the same event solution that would generate, trigger these alarms, alerts, and provide you back, as we just discussed before, business metrics. That's most important metrics for our business, which is recovery time, repair time, acknowledgement time, etc. And this is just another example. If we just review with you escalation process, how it's important So this process to be part of this observability platform, it must be part of this observability platform. What's more important, when you build up this observability platform, you build up not platform, you build up ecosystem. You let your customers, internal customers in my case, to use this ecosystem. So in other words, you're not going to set up all these indicators or objects or anything else. You let people, customers, to do this work because they know better what should be set up to be alert in case of something wrong. They know better what kind of thresholds or objects, SLOs, should be applied for this monitoring solution. And naturally, they know much better what severity should be linked to every possible case. So for this reason, again, we create ecosystem, observability ecosystem, if you wish, that could be used finally by customers, by people who know their applications better, businesses better, and they would do this work for us. And as I mentioned before, it's very important to comply with security and with regulations. And for this is very important, actually one of the factors that led us to move to Grafana Lab site, because Grafana uniquely provide ability to use and the platform as a service, but at the same time, Grafana Labs and open source let us to use all the software on premises. And for this reason, our cyber group and our meet requirements, and actually our deployment of observability platform, I would say right now practically everything is sitting inside on premises, and just a part of external metrics we still collect by using public cloud, and we push this data back to our on-premises. Again, it has been done for good reason. As I mentioned, for many industries, this is the most important criteria, and we just try to comply with all these requirements. As you can see, next slide actually would discuss ability of why actually we're just trying to find right infrastructure for our observability platform, and there is numerous ways to do this. We already discussed why we're going to do this on premises, but on premises it can be done by using physical servers, by using, let's say, private cloud, or by using Azure instances, by using VMware instances. Yet we decided to choose Kubernetes for many reasons. One of the reasons, ability to provide very, very elastic way to extend and provide scalability on the fly. And that is important. And it can be done on node level by using extension, auto extension by using worker nodes, or it can be done on horizontal level, another level, when you just simply can't change number of replicas for every container or microservices. And that can be done easily, and always would give you ability to fit new reality if your workload has been increased drastically. At least you can be sure, so you're always fine. So, and finally, is this reliable or not? Yet another case why Kubernetes is here, because when you do Kubernetes stuff, naturally you start to use CI/CD. In our case, this is a Helm and Terraform on the top of Helm. And just because this combination, it can be Jenkins, you name it, it can be anything. But the final point is to make it fast enough, just to, as I mentioned before, to increase your availability. And at the same time, to have to be safe enough. Just if something's going on wrong, it would not take too much time for you to roll back to original settings. In case of Kubernetes, this is a matter of minutes. You can deploy a new application or a new version during a couple of minutes. Same situation, something got saved, doesn't work well. you can't move it back for the same couple of minutes. And in this case, your downtime would be drastically different if you try to use standard approach. So keeping in mind what has been discussed right now, we choose this solution, which is a Grafana enterprise products. And this is a Kubernetes infrastructure that supports this product. And again, this is why, because it's open source, which is quite unique for any product, give you ability to use multiple components, and you shouldn't spend too much time to build up your own. Yeah, actually minimize development efforts, and naturally it would help you to speed up your deployment of your observability platform. Same time, it has a beauty to use enterprise products such as Grafana Enterprise, Jimmy, or Grafana Enterprise Logs, and that give you ability to treat your observability platform as a real mature product, because it would comply with regulations and with cyber requirements. And trust me, for many people, it's a very important statement. And finally, you still have options just to use as a hybrid and work with on-premises piece and with something that is going to be part of your PASS. And this is total, all this stuff give you, all these pieces, small pieces give you some sense of, so probably this is would be the most right decision. And yes, I almost forgot. The factor for many modern technologies such as Kubernetes, Prometheus, it's become de facto as a product of choice to monitor the environments. So finally, you know what we have to do. We're going to use Grafana Lab product, and we're going to use Kubernetes. Now, on this slide, you can see steps. Again, there is nothing extravagant there. This is a general steps that you would probably expect to do for every observability deployment. First, define the architectural approach. Second, build UAT environment. Set up self-monitoring before you're going to do anything else. Ability, now you have to provide ability for your internal customers, start to play with your dashboards and alerts and notification pieces. And finally, when everything is done, and when you're ready to provide your final configuration file, such as YAMLs, you move this to your delivery engineering, and those people would do work for production. So rule number one, no hands-on production environment. And this is probably the most right rule for any responsible customer. So let's start with our architectural approach. As you can see here, this is a standard way to do this. You see here and Jimmy, which is a Cortex. You see two replicas of Grafana Enterprise. You see Loki, of course, because we have to get all this log data and bring this on the central location. And of course, you see numerous number of Prometheus and exporters. And we're using Prometheus as a middle layer between Mega Prometheus, which is a Cortex or Jimmy, and all these exporters, in this case, vCenters, network devices, Amazon AC2, you can name anything. Actually, we even monitor printers by using this solution. And second piece that briefly describe you how we do monitoring for our external devices by using external Grafana cloud, and later we just bring this stuff back to the Grafana on premises that give us one big picture, safe picture that show an internal stuff and external stuff at the same time. So as I mentioned, we have to do some steps. First, we have to deploy Grafana Enterprise. Next is would be Jimmy or Cortex. After this, you have to deploy monitoring for infrastructure itself. And later, you can deploy Loki, exporters, and Prometheus deployment that would be your interface between your Jimmy and between your exporters. As a next step, it's just final result. As you can see, this is for my people on delivery team who just definitely would like to know. So there is no any pressure, disk pressure, memory pressure, CPU pressure, any psychological pressure on any node, if you wish. And this is one of the examples how we do monitoring for Kubernetes in general, Kubernetes environment. And here, this is example about namespace that specifically designated to run this observability platform. This is on the left side, all parts that are related to this one. Actually, it's not all, much more. On the left side, you see numbers that are related to this activity. So we are capable to monitor number of parts, utilization on every part, and this gives us ability to make it stable and predictable and avoid any situation when this environment is not ready to provide this service. Another couple of examples, quite interesting, has been discussed recently with Grafana support. This is a way to monitor unique situation. In this case, we monitor persistent volume for every part, and this has helped us to keep it in good shape, especially for GME metric, such as for GME services such as ingesters. Another example, this is how we monitor time when GME, it's just example, GME pushes data back to backend storage, in my case S3, but you can't, you understand this is a 10 or 100 different metrics that easily can be set up to be monitored to identify any potential problems. And finally, when we did this stuff, we just go into Loki, and Loki is going to bring data, collection data, collector log data to central collection, and later we can just connect this to Grafana, and we can start to monitor and set up notification for any log file solution. So, and finally, we have middle layer, as I mentioned before. It's a Prometheus that just grab data from every exporter and brings this data back to GME, which is a Cortex. And what was most important, as you can see, remote write, you always have to pay attention for this piece. You have to direct to right direction. So they will grab data from every exporter, and they push this data by using remote write to GME gateway. And at this point, you have all data in one central location. And now the final piece is we have to right now to understand how much resources we have to allocate for every part. And for this reason, we have to measure this. This is why we build up everything on UAT. So now when everything starts to work, we're going back to our Grafana. We specifically monitor how much CPU and memory taken by every Grafana, by every part on our observability namespace. And finally, based on this information, we can allocate appropriate resources, request and limit resources that give us ability to give enough resources to run the job. And same time, we're going to keep it on limit, do not create any problem for delivery team, because they would not feel comfortable if we just simply skip limits. When everything is done, we send these YAMLs to delivery team and they deploy in production. At this point, you have observability platform. Now you have to go back and start to do your event management. And few more slides would explain you what is our situation with notification process. So we pick up this notification process again by using Grafana or alert managers. And as I mentioned before, for us, it's very important to start to use special business metrics, such as time to recovery, time to repair, time to acknowledge. And this is exactly what we try to achieve by using this stuff. So in this case, on this slide, I just gave you probably the last presentation. When you use Loki, and we, by using Loki, monitor execution time for some specific job. And at the point when this job would exceed expected number of seconds, minutes, or hours, it would trigger alarm, such as a P2, such as a severity P2, and show job execution is not longer than expected. So up to this point, it's going to fire up a notification, and this notification in our case is going to pager duty. So as I mentioned, we are capable to bring this information back to Grafana, and by using, in our case, PagerDuty exporter, but I'm pretty sure exporter can be written for any other solution on the market. We're capable to see how much time has been taken to acknowledge this event and how much time has been taken to fix this problem. And that is the goal of all this observability activity. On the right side, actually, I just try to make it simple. Maybe it's not simple. There's one dimension that is standard dimension for any observability platform when you just collect data and analyze. And another dimension when you use this analysis, you're capable to create new set of metrics, business metrics, and based on these metrics, you can improve your business in general. So probably I just try to go through all this presentation. I knew, so it would take more, I'm pretty sure it should take more time, but we have to keep up this 20 minutes interval. So let me finish this presentation. You can find, I hope you can find a lot of useful information by using these links. And if you have any questions, you always can find me, or you can contact Grafana Lab, and we can discuss any question that you have concern about, or you would like to improve something, do something. Okay, thank you.